Thanks. Thank you, Guru. Yeah. Hello, everyone. Good afternoon. That's pleasure imparting my knowledge from the industry experience specifically, right? In the areas of data. I mean, I will not use the word machine learning or right now, but it's around data essentially, right? So, data at different levels, data at levels of making sense out of data, data at visualizations, data of multiple ways of capturing or consuming data per se. Now, having said that, I wanted to have these, screen is visible, Vidya. We have not shared any screen yet, so just we will do it actually, right? Yeah.
Yeah.
Okay. Uh, no, I haven't shared anything yet, so obviously you can't see anything. Just see the Zoom screen right now. Now, having said that, I want these whatever we have the sessions planned out across these 3 days, right? I wanted to have it as interactive as possible, right? Interactive in the sense that uh, I will be kind of not asking questions realistically, but more in terms of asking your thoughts, your suggestions. Also, I'll be trying to give you a lot of industry-wide case studies, essentially, right, in the areas we're discussing. And I want you to ask questions as much as you can, right? I mean, be it a very small question or a big question or a complex question or simple, irrespective. I want it to be interactive as possible, because this kind of session, although it's a kind of 4-hour sessions per day, it not want it to get as I'm more interactive. I want it as possible. That's the whole idea behind it, right? And probably, since you guys are all the faculty members from different engineering colleges, of course it would be very interesting to know your thought processes, what you see, what your experience is from the technology, and how they kind of combine or they wet together in the when you are teaching the folks in the engineering colleges, right? So that's the idea behind it. And this session will also help you not only your benefit perspective. I'll try to make it that tomorrow down the line, when you are teaching the folks at the engineering colleges or any other colleges, right, how will you put across these kind of technologies in the curriculum, if maybe so, and how will that improve in the industry, what the industry is really wanting, what they want in the students or the freshers, etc., etc. That will help you in that perspective as well, right? So that's the whole idea behind it. Before I start, any other kind of, I just want to open this question to all of you. Any expectations that you have in mind, any kind of thought process you have in mind, that this is something which you will be coming out after this 3-day faculty development program. This is something I'll be carrying in my bag, and with my knowledge, this any kind of expectations you have in mind, essentially.
Excuse me, sir.
Yeah, go ahead.
Yeah. So, are we going to touch upon some latest hands-on tools
Yes, I
during
do
this?
plan to do that. Dr. Gauri, right? If I'm not wrong.
Yeah.
Yeah,
Yeah. Yeah.
yeah, Dr. Gauri, yes, I do plan to do that thing, right? And I do plan to touch upon Python typically, right? Not today, but tomorrow I plan to do that little thing. And Python implementing some of the machine learning tools, particularly. That's what the
Okay. Okay.
okay.
So, in which particular is there any particular domain for these machine learning implementations, like natural
Uh,
language processing or some biotechnology related domain?
no. Okay. NLP and these things. NLP is not a domain realistically. It's one concept of machine learning, right?
Machine learning. Yes. Yes.
So when I'm saying domain, what I understand from domain perspective, Dr. Corey, is in terms of the industry domain or use case is concerned, right? I'll be
Okay.
talking
So,
about.
applications in that way.
Correct, correct.
Yeah.
So I'll be talking about in terms of in with respect to the telecom domain particularly as well. I'll be talking in terms of financial fintech industry domain as well. When we start to implement the data sets which I'll be using, right, will be those
Mhm.
specific areas, right?
Okay.
I mean,
Okay.
data science as such, as a life cycle perspective, right, is not not specific to a particular domain. It can be applied to any domain as you long you have the data behind it. So they have
Yes.
its own life cycle, they have its own modules, own
Right.
etc., which can be applied to any domain, right? Obviously, the
Right.
data belongs to a domain. The questions, the business impact, what you're answering from the machine learning is
Hmm.
is specific for that domain itself, but not the whole life cycle, essentially.
Yeah. Yeah.
Yeah.
Okay then. So main focus would be on Python.
Yeah, that's the idea. I understand the fact as well that R is also widely used, right? And R is also widely used, especially in educational institutions, right? Be it research institutes or educational institutions. In fact, in colleges, I have seen a lot of R being used, but in reality, in the industry, typically we use Python, particularly for the huge amount of growth happening in Python in the community area, and
Yes.
the support that they have, essentially, right?
We
So
also are using Python only in our curriculum. So
okay,
that's a
okay,
really great language.
sure, sure,
Yeah.
sure, absolutely.
Okay. Then
Any,
so which
yeah.
algorithms in specific machine
We'll
learning
be
algorithm?
talking. In machine learning, we'll be covering certain areas of logistic regression, right? In terms of
Okay.
supervised classification is concerned, right?
Yeah.
We're talking about clustering as well using k-means
Okay.
essentially.
And any unsupervised or ensemble type of
Unsupervised,
learning
as I mentioned, clustering typically.
clustering? Yes. Okay.
That's an unsupervised part of it. Ensemble mechanism, it can be applied for both clustering as well as unsupervised and supervised. So
Yeah.
we'll touch upon the particular part of boosting algorithms as well, right, for
Okay.
machine learning.
Okay. That's great.
Yeah,
Thank you.
yeah. Any other thought process, any other expectations apart from what Dr. Gauri was mentioning? Maybe if somebody can go on mute, I can hear their television voices in the background. That will be helpful.
Yeah.
Thank you.
Also, you can post it on the chat box.
Chat.
Sure. Yeah.
Any of your questions, please do post it on chat.
From the I'm talking in the terms of the expectation is concerned, right?
Yeah, yeah.
Okay, let me start. I hope the screen is viewable, right?
Yes, sir. Yes.
Perfect. Okay, first question to you on the first slide itself, right? Have you heard this FSDS thing recently? Have you heard about it? FSDS, full stack data scientist. Or let me take a step back. Have you heard about full stack developers? And if yes, then what is it about? Yes. Yeah. Dharmendra probably can put it in the,
Yes.
everyone.
Yes.
Yes, we have heard about it. So it's a
Uh,
complete software development life cycle. So starting
uh-huh.
from the understanding the requirements, analyzing it till the final product delivery, and then
Correct.
the loop is again taken ahead.
Correct. So yeah, quite
Yes,
right. Yeah.
yes. So
Yeah.
that is full stack development. Madam has already told, but in full stack, that person or the corresponding developer should know the front end, back end, as well as the that is
Exactly.
the server
Exactly.
side technology also.
Correct. Now, what is interesting here, we talk about the backend part, right, which is the server side technologies, let's say, right? We talk about the front end part, let's say React, for example, or JavaScript technology, for example, right? But also, there are two important pieces we miss typically, right? Is the part of DevOps, essentially, right? DevOps, in the sense, is becoming an extremely critical factor nowadays, right? When we say DevOps, I mean the fact that how do you deploy things? How do you monitor the deployed things on the application side, right? How do you, gather the infrastructure on the cloud or on premise, right? How much in terms of the course you will give? What is the memory you will give? Will you use a CPU or a GPU, etc., right? What is for the development environment, what is for the test environment, what is for the client testing environment, what is for the production environment, right? How will you scale the applications, how you make sure the fact that they are properly load balanced, right? So the full stack developer typically also is expected, and that's how the reality is, that not only you should know how to develop things, at least you should know how to deploy things as well. At least you should know the tools, how to deploy, how to do the continuous integration and development as well, right? And the expectation is increasing so and so much, right? I mean, not only the technical part, the person should be also well adversed in the part of communication as well. He should be able to, he or she should be able to communicate with the clients, understand that, as what Gauri was saying, understand the requirements, right? Try to map the requirements with whatever technical requirements you have. So that is expectation, and that's how things have been moving typically. Uh, in the last few years. At the same time, right, we have been hearing this term of data scientist, full stack data scientist, you know, a full stack data scientist perspective is that, one sec, okay, it's no longer the fact that the moment we talk about data, right? The moment we talk about, we talk, say that, data is gold. You can find out patterns. You have data-driven organizations, etc., etc. Right? Now, what happens over there is the expectation in the industry is becoming so so in terms of high expectations from these data scientists, that you are not required only to make models, you are not required only to make good algorithms, you are not required only to show me accuracy, right? That even because these algorithms typically, these models typically, or I should say the algorithms typically, are there in the market. Okay, I mean, if I hire probably a person who has 1 year experience, for example, right, who has done courses on data science, for example, and he or she can do the same thing. What is your value add? What is your value propositions essentially, right? Which means the scope of the work of the so-called FSDS or full stack data scientist in the overall life cycle becomes larger, right? What does that mean? That means, they should be able to understand the business needs. They should be able to explain why this particular machine learning approach generates a better ROI than whatever you are doing today, right? They should be able to communicate to the particular end consumers who is using your model, right? So basically understanding and executing not just the data analysis part of it, but the model deployment, that model development, the business requirement, the problem understanding, the data acquisition part as well, right? The part of model building or the model development, model deployment, model monitoring. That is the expectation is becoming in the industry, right? Some might question here that, sir, that, okay, you know what? We heard about data engineering. Anybody heard about data engineering and data science? What is the difference typically? Any thoughts on that? Data engineering versus data science in the market, have you heard about it? What is
Data scientist is more from a statistics perspective and algorithms and uh, like time complexity, space complexity, and from algorithm perspective, whereas
okay?
data engineering is more from structured, unstructured data, various resources from where data is being gathered, and more often data cleaning, data pre-processing part.
Okay, fair.
Right. 1 minute.
Yeah.
The data engineers are focused on building infrastructure and architecture for data generation, whereas data scientists are focused on advanced mathematics and statistical analysis. So simply, data scientists depend on data engineers.
Agreed. Agreed. But the reality is becoming, right? The so-called full stack data scientists typically, right, are also expected to know how to create the pipelines. For example, in data engineering structures, right? What is happening over there? You are given a variety of data sources, be it structured, be it unstructured, be it databases, or be it SCSV files, or be it images, audios, same structures file. You need to gather all these sources at one place, to pull data from that particular thing, You have maybe REST APIs, essentially. You call data from the different places, and you start creating the so-called new buzzword called data lake, right? I mean, you don't know exactly why you are getting the data, but you eventually you will create some kind of pattern, some kind of correlation in the database and help the business. But the expectation from this full stack data scientist right now is also that you have an expertise typically in building these data pipelines as well, right? You need to have some kind of a common unified structure of the data as well, right? Obviously. So what that does means is that right from the beginning of problem understanding, business understanding, uh, uh, talking to business spokes, right? From the part of acquisition of data, model building, development, monitoring, and final part is, which we all miss, is that the visualization part or the telling of stories, right? Whatever you have built, essentially, how do you convey that message in a very nice story? How can you weave a story using visualization methods so your impact is high on the business, right? So what does that mean? That means that you're becoming, or you're trying to make, basically jack of all trades, right? Now if you're making a person who's kind of jack of all trades, it's impossible, right? So basically you cannot be master of none again. So there are so many pockets over there, as I mentioned, right? You have business particular part, the data acquisition part, the model part, the data cleaning part, the visualization part, the deployment part. You cannot be master of everything, it's impossible, right? But you should have at least some knowledge that how do you build a pipeline, essentially, right? But how, what are the technologies typically used in the pipeline? In those areas, what happens over there, that data scientists, right, if they know about these areas typically, right, what it would help eventually is that they would be or they are expected that at least some areas they will be masters, essentially, right? Which somebody rightly mentioned, the advanced statistics part, essentially, or the machine learning part of it, or the linear algebra part of it, right? And they probably, maybe out of a rank of 1 to 5, they're good in maybe data cleaning, the algorithms, the mathematics part, maybe around 4 or 3.5 or 4. And the other parts, maybe, let's say, data acquisition perspective, let's say around 2 or 2.5. Visualization maybe around 2.5. Business maybe around 3, because business is very important, because they are the ones or sole point of contact who would understand what the business problem is, or what the challenge is, and how they would eventually relate. When you create an algorithm, how would it impact your business problem, essentially? So of course the scope is widened. You cannot be master of everything. You cannot be having depth of knowledge of everything, but data scientists companies is a part of the statistics background. So now, having said that, right, I mean, the initiatives, or the key skills, basically, and now you will see as well, even you are not a statistician typically, right? I mean, statisticians, again, are not always being hired in the organizations, in all orgs, in all startups, or in all big organizations, right? In a team of data science, right? What is again expected, that of course, if you're doing data science, if you're implementing algorithms, the obvious expectation is that you should know a bit of statistics, of course, right? I would not use the word bit, but a good amount of statistics knowledge is required over there as well. So it's a culmination of basically computer science, programming, mathematics, statistics, business communication, visualization techniques. That's what eventually culminates a kind of a data scientist, or a full stack data scientist, with the particular how much I know about visualization versus how much I know about model, how much I know algorithm, how much of business, etc. But that is the expectation of a full stack data scientist, essentially, right? And okay, before jumping on this thing, right? Any questions, any thoughts here in terms of what you have heard about, or what you are thinking in the industry versus what I'm telling you right now? Any gaps you want to bridge up over here? Okay, fine. Now, here I'm trying to start in terms of at a broad level, right? If you see over here, different domains I've mentioned over here, right? When I'm saying domain, right, I mean this. I mean healthcare is a domain for me. Travel is and hospitality is a domain for me. credit and insurance is a domain for me. Sales is a domain for me, right? And now, what are the different kind of applications we see day in and day out, right? Sometimes we don't even know we are already consuming machine learning applications in these domains, and we use it essentially. For example, let's say the part of travel, right? The prices which you see typically on your, when you search over your different, like Make My Trips of the world or Clear Trips or these agents, typically when you search the flights on different kind of days, on different kind of, when from your travel day versus the period when you're searching, right, you see different prices, right? So the price is dynamic essentially. So these dynamic pricing, right, depends upon a lot of factors, a lot of features. When you're traveling, where are you traveling, what is the particular frequency, which time you're traveling, right, etc., etc. And essentially, you will see a lot of pricing being fluctuating from day in and day out, which is again an output of these AI or machine learning applications again, right? Now, when I'm using the word AI and machine learning, don't get, kind of confused here, because the way I see AI or artificial intelligence is a big, big umbrella, huge umbrella, right? ML and data science is a subset of the particular AI itself, essentially. Okay. ML is not AI, it's a subset of AI, essentially. Okay. And deep learning, if you have heard about it, deep learning is basically again a subset of machine learning, right? That is how I put it. AI is huge in nature typically, right? And ML is a subset of a particular thing, and DL is basically again a subset of the particular machine learning. Now, when you talk about these domains, right, another very interesting thing, right, you have heard about demand forecasting, right? How do you forecast your demands? How it will help that forecasting in terms of your supply chain inventory stocks? How it will help you to reduce your inventory stocks? How it will help you to, match your supplies essentially, right? So demand forecasting has been used essentially in sales as well. How much discount you'll be giving, right? What is the percentage discount for this customer versus the other customer, right? Again, an output of the ML world, right? That's been using. Finance and banking and credit and insurance, right? Extremely high usage, right? Today, for example, when you go for a bank for a, let's say, a car loan or a home loan, right? They do a huge amount of, you've heard about this credit check, credit history typically, right? You say that, what's your credit score, right? You have a 770 plus or 700 plus. That's just one of the inputs essentially, right? Not the only input, right? They see your particular, your existing dependencies, existing loans, your demographics, your previous history, etc., etc. Your existing organization, how long have you been there, hundreds of things. Again, these all your data of the customer data are already there with the particular banking financial organizations of different customers, of different types of customers. They use huge amount of ML over there and structural data ML typically, right? Uh, Typically, I'm saying because some of the organizations are now also using social media data as well, but structurally they are using, or typically they are using structured data, right? I mean, should I give the home loan or the car loan or not, essentially, with a certain of probability, correct? So again, it's an ML output in the industry being used, right? Talk about analysis of your sentiments, right? For example, in social media world, we talk about that, what are you writing about the product, for example, right? When I say social media, I am not restricting myself over here about only Facebooks or Twitters essentially, right? Even the blogs and the forums are also social media as well, right? Anywhere you're able to collaborate with multiple people, it's a social media platform essentially, right? So people talk about different brands, different products, their experiences, right? What are they talking about, right? That's then the particular the part of NLP application essentially, what as what Gauri was saying, NLP part of it, right? So we are already surrounded by, I mean, but think about it, right? Today, when you are searching products, right, or if you are seeing, let's say, your web series today, for example, or the movies typically, right, on the different OTT platforms, the Amazons or the Prime Videos or the Netflixes or the particular multiple other The channels like Hotstars, Disney, they have gone online, right? You will see a lot of recommendations happening, right? And how do you think that's happening? Correct? Those recommendations are again a product or an output of whatever not only you have browsed, not only you have seen, but similar users like you have seen that particular thing itself, right? So, you know, what I'm only saying here is that be it today you're opening Zomato, for example, you're watching a movie, right? You're writing something on the particular Facebook post, you're writing something particular, you're buying a ticket, you're going to the healthcare system to find your, what can happen for this particular test itself, the disease prediction, you are getting some discounts, you are applying some car loans. We are already with the onset of data and its usage of data, we are already kind of surrounded by different kind of machine learning outputs already. So in a way or so, without probably be knowing it sometimes as well, we are already being using it essentially, right? Any other thoughts here? Just want to take a pause here for these minutes. Any other thoughts here where you have seen, from your experiences, where it's used heavily, the machine learning part of it, or the output machine learning, where you are already kind of a consumer already, where it is being used heavily?
In offering the suggestions for similar products.
Mm-hmm. Sorry? Yeah, basically in the e-commerce world you are saying, correct? Is that correct or what you're referring here?
Yeah.
Correct. Again, absolutely. Very good point. In basically e-tail, which we typically call from retail to e-tail, and in the e-commerce on the online shopping business or online shopping world, right, where you are buying something, right, where you are thinking about to you have browsed something, right. The It's very interesting actually. Let me take a pause here to go over that thing since you brought the point. Let's say today you are the very first login, for example, in Amazon, let's say, and I think Amazon because it's a big fish in the market, right, in terms of the e-commerce is concerned. Let's say you are going for the very, very first time in Amazon, never ever from your profile, you have never have a profile created, for example, and the first time you're going to a particular Chrome web, this thing on your laptop or your mobile, etc., etc., you start using Amazon. You know what happens? The first thing you will see, you have never logged in before, never had a profile. The first time you're creating a profile, essentially, right? You know what you will see? You will still see some items which are already recommended to you, and that's they have their logic of popular items or viral items, etc., etc., and they push to you. The moment you start browsing, the moment you find your products which you think are relevant for you, the recommendation typically changes over a period of time, right? As you said, similar products I'm buying, right? People who has bought this has also bought this, essentially, right? Collaborative in nature, essentially, right? I am buying, let's say I am buying, for example, or I have bought, let's say, a can of Coke, and let's say a slice of pizza, let's say, right? And the other person, gentleman, has bought a particular slice of pizza, and along with that some chicken fries as well. Down the line what's happening is that I will be also recommended with the chicken fries, and the other gentleman over there will be recommended with the particular bottle of the can of Coke, right? And that's collaborative filter I'm talking about. So a lot of usage over here in terms of when you log in for the first time, what do you see versus over a period of time when you have browsed a lot, you have added some things in the cart, or you bought something. Over a period of time, the recommendation changes. What does that mean? That over a period of time, the system, the backend system, when it is churning out more data, right? When it is able to process more data, it is becoming more and more knowledgeable. Hence, the recommendations becomes more and more personalized, more and more specific to the end consumers. Make sense, everyone?
Yes, sir.
Yeah. Maybe you don't have to speak as well. If you don't want to, you can probably give a thumbs up or yes on the chat. That should also do. So I'm just able to understand that you're able to take it or not. That's my whole point, and make it interactive as possible, right? Okay.
So specifically in natural language processing,
Mm-hmm.
the way one understand the text, analyze it, or have
Mm-hmm.
inference from that, or the way
Correct.
express varies a lot. So
Correct.
whenever it's a practical use case
Mm.
where the machine learning algorithms outcome in most of the cases will be objective way. So the subjective and objective, how convincing it is for the actual
Excellent.
for any use case.
Excellent question. Now, not it is always objective in nature, right? If I take an example, let's say, if I talk about machine learning, right, and if I let's say talk about only supervised and let's say unsupervised, typically, right? Supervised in that particular sense, if you see, right, you have an objective, isn't it? In supervised learning of machine learning, right, you know what you want to do, you know what is your target is, isn't it? Correct.
Yeah, agree. Yeah.
Correct. Agree. But in case of unsupervised, it's actually more interesting because you're dealing with the unknown. In unsupervised learning, let's say if I give an example of clustering, right? Do you have any target variable over there? No.
Again, it's the way we find out the inferences, the
Exactly.
data
E-
scientist.
Exactly.
Mhm.
Exactly. So basically, if you think about a clustering kind of implementation of unsupervised learning, right? You are trying to understand segments of data of your entities in the data, essentially. Correct? You do not have any target variable, essentially, in clustering. Correct? Yeah, go ahead. Hello?
So for the same data set,
Uh,
if it is given to X data scientist and Y data scientist, the outcome
mhm.
is different. No?
No, exactly. I'm not talking about X and Y data. I'm talking about the particular, as you said, subjective and objective, right?
Hmm,
If
hmm.
I talk about objective part, essentially, I'm giving example of supervised learning of machine
Yeah.
learning, where you know what is your target, where you know
Hmm.
what you have to predict, etc., right? If it's
Right.
unsupervised, it is very not. I will not use the word unsubjective in nature, but it is
Hmm.
not also at all objective in nature, right? You do not know what can be the pattern. You do not
Yeah.
can be the same at all. You have no clue whatsoever, which makes it more interesting, right? You kind of hitting the unknown.
Yes.
And what you're saying, absolutely correct, is in terms of NLP perspective, right? In NLP as well, right? If you think about in any kind of NLP, right? I mean, one is let's take an example. Otherwise, we will talk all abstract, essentially, right? Let's take example of let's say right now in your Gmail, for example, or your personal email per se, right? There are
Mm-hmm.
probably a few of the hundreds of emails are coming in, right? Bombarding, where your Gmail is kind of able to understand whether it's an email, it's a legitimate email or a spam email or not, isn't it?
Hmm. Yeah.
So
Yeah.
that, how does Gmail do that, right? Has it done in one day? Absolutely not, right? Over a period of time.
Yeah.
You are having a lot of rules over there, essentially, right? The email
Hmm.
has this amount of text, the subject line has this particular thing. If the email has content about some kind of dollar prices, etc., some obnoxious domain particularly has come from a particular thing, the email has come from multiple rules. When you
Hmm.
are using all these different rules, different kind of applicability, right, you are
Mm-hmm.
able to label the particular email as it's a spam or not spam. Essentially, what I'm saying over here is that although it's subjective in nature, still in this case, you will having the history data as well, which has earlier emails which are being told as spam or not spam, isn't it? Right?
Yeah. Yeah.
Basically, you're classifying the data essentially. Again, supervised comes into picture, but you're classifying based on the context of the email or the email content, which is subjective in nature particularly. Make sense?
Yeah. 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 So the way algorithm predict,
Hmm.
let's say same example, spam or ham,
Mm-hmm.
how convincing it is for the like actual and the predicted one, like how whenever it is actual practical use case, how convincing the outcome of machine learning algorithm for the actual client.
You mean from the business
Yeah,
acceptance is concerned? That's what I'm saying.
right, absolutely.
Again, I'll give you an example. Can somebody go on mute? You hear a lot of background noise, guys. I think the other gentleman.
You have muted everyone.
Okay, thanks, Guru. Yeah, so no, I think we probably unmute the gentleman who was speaking to me. In that way, it will be more interactive. That's okay, Guru. So in that way, from the business acceptance is concerned, right? I'll give you an example. Does it acceptance happens in one day? No. It takes time. Yes. How much time? Depends.
Mhm.
The
Okay.
point is, and that's how the reality is. I'm telling you exactly hard reality in the like in the application in the industry is concerned. We were dealing with a client, right, who had a lot of the data coming in. They were a particular wholesale retailer, so they had a huge number of suppliers, right? And let me bring out that particular thing since you brought the point. Let me bring that particular study in 1 second. I think I have it somewhere. 1 sec. Give me a moment here. I have that. Since we're talking about industry level case studies, it makes sense over here to show that thing as well. Studies. Yeah. Let me know if you're able to see the screen. Oh, not sure. Sorry. Are you able to see the screen right now?
Yes, yes.
Yeah.
Perfect. So this is one example to your particular point, a very, very specific case study I'm picking up over here is this was a kind of an email sorting engine for a large retailer. Okay, so the business problem was that they had this wholesale retailer in North America, and they had a huge number of suppliers typically, and they had to register themselves with the wholesaler every year, right? A renewal perspective is concerned, or a new supplier has come essentially, right? So these guys, over a period of 6 months, they used to bombard the emails, right, for different kind of emails they're sending to the supplier, to the wholesale retailers, the wholesalers. And the existing process essentially was that they had around 6 or 7 people over there in the organization who used to read those emails. Think about it, read those emails, and over a period of time, you're getting around 500 to 600 emails per day for one person. It's a daunting task, right? It's a tedious task, right? And these emails would have questions about it's a email about some kind of queries or change request or a claim or some complaints or some undeliverables, etc., right? So these basically are what essentially are my labels of a particular email, right? And the previous process I mentioned, they had a shared database typically, and they used to use a particular thing. And what we did over here was what I'm using the word NLU, if you see over here, right? Instead of NLP, I mean, NLU is nothing but an eventual byproduct of NLP, natural language understanding, right? And we took around 3 years of their previous data, right, and tried to understand the particular emails, their content, and they also had some hard rules as well. But keeping aside the hard rules, from the natural context is concerned, subjectively, we took this particular stuff, and it took around 2 cycles essentially. And I said 2 cycles. We give the production. I mean, before that, we had a lot of testing been done, client acceptance testing, etc., etc. But obviously there will be scenarios where you're not able to understand at all that what this email talks about. It can so happen this email can talk about a label query versus a CR both. It can be all only CR as well. So we had to, put out the weightage as well. We had to understand the context of every particular sentence essentially in the emails. And over a period of time, let's say 2 or 3 cycles, it went to an accuracy of around 80 to 90%. The first accuracy level came around 65%, which is quite good, which is pretty good in the first phase. And then slowly in understanding that when they understood the particular, the automation, the innovation process, how it will help the business, because eventually it will help your operation cost, your training cost. It will, instead of 7 people, you'll probably have one person over there doing the job essentially. They understood the value of the particular thing, and eventually it went into acceptance over 2 or 3 cycles essentially. So that's how it goes, right?
Yeah, thank you so much for explaining in this particular use case in so detail.
No problem. Okay, so as we're discussing, right, we talked about different, industry involvement, different industry applications, typically, right, how they are using it, etc., etc. And so overall, the technology and tools in full stack, right? I mean, kind of a routine work which data scientists typically do, starting from raw data, processing them, applying models and analysis, making predictions over there, data-driven products they are using as well, BI, and then finally the last leg typically. That's how it works in the current scenario. So, I mean, data science, as I was saying earlier, right? And somebody was mentioning that, it's within the periphery of advanced machine learning and analytics and statistics part. Quite right, absolutely. But it's kind of a culmination again, a culmination in terms of, a culmination of machine learning, hacking skills, research skills, math statistics, in terms of expertise as well, right? So that is where I was talking about that. That's kind of a culmination which is being talked out essentially over here, right? Now, bringing all this together, we are now hearing what are the things a data scientist or a full stack data scientist should do and should not do versus the tools they are using. So it's a plethora of tools in the market. Plethora. I'm using the word plethora because you don't know exactly when to use what, right? So that's again one challenge, that for these kind of applications, this is what I'm expected to do. For example, give an example over here, right? I mean, if you think about here, these kind of, if I label these tools typically, right? Probably many of you have heard about most of the tools over here, possibly, right? Let's say Kafka is for streaming typically, for messaging architecture. Spark, distributed system over here, right? Cassandra, again, unstructured or NoSQL DB typical, right? MySQL, structured DB, basically, right? Then you have MongoDB, again, NoSQL DB. You have Jenkins for DevOps, typically, for CI/CD. You have Dockerization for dockering your whole application to deploy, right? You have the Python language. You have the Flask for APIs. You have Node for the particular, again, for backend as well as using for JavaScript applications. You have Matplotlib in Python itself to create charts. You have Seaborn, another chart Seaborn built on Matplotlib. You have Pandas in Python for data analysis is concerned. NumPy, again, for data analysis and mathematical work, right? So you have a plethora of tools essentially happening over here, right? And again, data, and not only these I'm talking about, which are tools which are there, where you kind of start coding on those, right? But think about the products which are there already, who are giving you out of the box algorithms, H2O, OpenAI, right? I mean, these together, right? I mean, it requires a lot to understand. Even if the tool is giving it to me just like that, I need to still understand that what is exactly happening in the background, at least to understand that the whole flow is concerned. So generally, for different kind of usage or different kind of application. This is typically how the data scientists use different kind of tools or packages or platforms or environments or the whole dockerization, the streaming architecture, distributed system, like a particular thing. So it's overwhelming sometimes, definitely, right? But again, today, what works today, for example, right? Maybe after 6 months or one down the line, a new package comes in. It makes even life easier. So you have to grasp that particular thing and make sure you're on the right track. And this has happened significantly in data science, and particularly in Python. I have seen, because I have been following that thing very closely, the kind of packages which you get in Python, which are reusable packages, right? I mean, you just do a pip install in Python, right? And you know what to use in the functions. It becomes a cakewalk for the programmers, essentially, right? But again, which essentially means I need to be on the top of everything. I need to top off the perspective of that what packages I should use, which I should not use, etc., etc. You can do one work probably or one objective maybe in 100 ways. In one of the ways, you can have 100 lines of code. In one, it can be 2 lines of code. It is up to you. How do you use it? How do you optimize your particular design and architecture? And that's which eventually means that we have to be top of the things, in the sense that what are the new things? What are the new libraries? What are the new packages which are coming in Python, for example, right? Which makes an always, an iterative way that you keep on learning and learning, and there's no end to it, essentially, right? So data scientist deals typically with these kind of tools, essentially, right? Across this plethora of tools. So a full stack DS is basically a mix of a DS, data scientist, and an ML engineer, and can design end-to-end ML project and software, essentially, right? Any questions here till now? We are just topping the hour right now. So I want to take a pause here. Any questions you have, or any suggestions, or any thoughts? Probably you can put on the chat, or you can unmute yourself, whichever way it works for you. No questions? Fantastic. Please feel free to ask any questions, anything which you have in mind. We'll be happy to answer. Okay, fine. Yeah, somebody had a question? I heard some voice, that's what I'm asking. Okay, fine. Now, tell me something here. Again, a question for you, right? You must have, and definitely I'm presuming you must, and you have at least read about or used it, right? That in the earlier days, when I'm saying earlier days, I mean basically around 10 years back or 15 years back or even 5 years back, right? Or even till now, we use a lot, right? The way you used to handle data, right? Typically, I mean, the way you used to handle data, the way you used to play with data, right? What were your typical ways of doing the thing? And I mean, I'm saying that I'm talking about strictly about database or data warehouses, which has been there. It's still there, definitely. But primarily the structured data typically. How were you handling data? Or let's say, how were you doing, let's say you have a business requirement, and what would be your next step in the data world? Basically, you have some business objective, you have a problem understanding, and then you start designing your whole solution, right? When you design that whole solution, right, how would you design of, or rather think of design the whole database and data warehouses? How do you do that? Sorry? Hello? Yeah.
No, sir, nothing.
Okay. So any thoughts here? Any suggestions here that in the previous is a question clear in the first place that earlier days, let's say 10 years back, when you had a business requirement or a problem understanding, etc., etc., uh, how would you design the data architecture? How would you do that? Maybe in few lines or maybe few words. Would be happy to hear. It's okay if you're wrong. That's absolutely fine.
uh,
Yeah, go ahead.
by using unstructured format like Excel or other formats. So we were using that mechanism, but it is
Hmm,
not suitable for the big data.
correct. First of all, Excel is not unstructured, it's structured completely. Number one. Okay. Excel, anything which is basically structured, meaning basically has a set of rows and columns essentially. But I get your
Okay,
yeah.
is it semi-structured, no, sir?
No, Excel is definitely structured. A CSV file,
Okay.
typically, for example, is structured data. It has a set of rows and columns. Semi-structured is something like an XML is semi-structured. JSON, semi-structured. Parquet, Parquet, semi-structured. But any kind of rows and columns typically you have in the right format is structured data format. Right?
Sir, can I comment?
Yeah, go ahead.
Sir, in earlier days, we use RDBMS. For that, we have used star schema, snowflake schema. These are the things.
Correct.
And then we have utilized the LAMP stack for modeling and
Correct.
web-based program.
Correct. But excellent point. But whatever you have been doing or whatever we have been doing, right, in those star schemas or data warehouses, normalization of data, in all these approaches, what was our assumption? What was our presumption, or I should say, that the business requirement is like this. Hence, the business requirement wants these questions to be answered. Hence, the business requirement requires these metrics, calculations, right? When you are designing your data warehouses earlier, right? When you used to do it earlier, we used to keep the business requirement in mind, essentially, right? We used to remember those star schemas, those attributes, those transactional data, those aggregate data typically, right? We used to create them as per the need, how the business used to want it, isn't it?
Yes, sir.
Right? Agreed, everyone? So having said that, now the whole ball game of data has completely changed, right? It's something like, in fact, I have a specific this thing. Let me just show that thing to you across. Uh, One sec. Hold on a minute. And one sec. Yeah. Let me share this thing. It'll be helpful. You see this framework, right? It's very interesting, right? Business driven approach versus data driven approach, right? You have the business stakeholders groups, right, who are your clients or your customers. They have a set of objectives, right, which can be made by certain initiatives which answers specific questions, right? These initiatives or these projects or these applications the questions will be answered using data, right? And if you remember, in the earlier days, we used to have this, your database structure being done, database schema being done, normalization, the whole attributes and column funda itself was completely and mostly dependent on what the business is wanting. Hence, I would like to structure the data in this particular way, right? I would have these kind of joins, this kind of transactional data, right? But now, why I'm calling out this particular piece essentially is because now the game has changed. The reason being, you do not know what the data can answer for you, right? You do not know, you have no clue altogether that what kind of metrics, what kind of impact, what kind of questions it will answer, what kind of correlation, what kind of pattern it will bring. You don't know that essentially. So handling data itself is not about designing the data nowadays as per this requirement. Rather, you keep on adding the data as the way it is, storing them, persisting them, and then probably doing some kind of unifying or a common platform approach and put it into one place, a database or on distributed system per se, typically in Hadoop HDFS, for example, because data can be used or data can suggest questions, right, which can address the initiative that can meet the objective for the stakeholders. I see marrying them, the one of business driven approach versus data driven approach, together is the right combination for data science, right? You can have 1, 2, 3, 4, 5 business requirements, and by seeing the data, you not only answer these 5 requirements, but you also answer 6, 7, 8, 9, 10 as well. So handling of data typically, right? Handling of data typically over there is being changed. The whole concept of handling data typically, for example, if I talk about, let's say the databases modeling, and mind you, I am not saying the DBMS has changed realistically. The fundamental of DBMS or RDBMS or data modeling, that has not changed, right? But how are you designing your databases? How are you designing your attributes and columns? Should we even store the data itself or not? Was a question asked probably 10 years back. We don't ask the question right now, right? I don't know that data can be a very important point in terms of correlation or some driving factor in my business, essentially. I store it irrespective, right? So data modeling typically, right? Data modeling typically, those has been there of requirements gathering, data modeling concept, logical data modeling, physical data modeling, and this I think you guys also have been teaching to many of your students as well, which is nothing wrong in there. But how it has been done versus how do you handle data nowadays, which we typically call in quotes big data, is very, very different, right? So let me ask you this question, a small quiz over here. In your way of data modeling, right, which is the correct order typically for data modeling process? This I'm sure every one of you can answer. Probably you can put in the chat which option 1 and 2, 3 or 4.
Sir, 4.
Others? Ashwin, it can't be C, it has to be D, number 4, right? You can't go to order of modeling of conceptual to physical and logical. Go to conceptual, then logical, then physical comes in the picture, essentially. Okay, perfect. So this,
Sir,
yeah.
Sir, meaning of physical means that means after getting the actual data or the information, then we will store it into our
Data
physical
modeling
system.
process typically, right? Basically the hard data schemas typically, essentially, they are those particular parts.
Okay, what is the meaning of physical here? So that's why I'm asking.
Okay, the physical typically, right? Okay, let me ask you this thing, right? Create an update, for example, say conceptual data model basically, or a physical, the tables, the columns, the key indices, the triggers. essentially. The point?
Okay.
Okay. Right. Conceptual is basically what? Conceptual is basically nothing but your entities, your subtypes, your attributes, your relationships, your entity rules, those kind of things essentially. Okay. Okay. Now, this we are all aware, right? And most of us are aware typically, right? How it works. I will take a quick thing, right? Over here. I mean, the key points we know, right? Data organization, use cases, having a well thought organized data. Again, dependent, very much hard dependent on the business is concerned, the business requirement is concerned, right? You plan ahead, it's an iterative process. We all know this particular. Any clue who does typically data modeling, or who should focus on learning data modeling? Any idea that little thing? Who should focus on data modeling?
Business analyst.
I don't have the option over here.
Okay.
I have, I think, 4 options. I probably should have added, but anyways, who does data modeling and who should focus on learning of data modeling? Maybe the second question. What should be response?
Okay. Options you have given.
Data modeling.
Thank you so much
Data.
for your
Who should
introduction about corporate relations office. So now I will be introducing students with various opportunities that you get after completion of your engineering. So it is very important to pursue higher education after completion of your graduation.
Can the
also.
gentleman in the other thing can mute?
I think data scientist.
Of engineering, so are worried like how we need to complete 4 years of engineering. But
Guru?
Data
at
scientist.
MIT Academy of Engineering.
Guru,
Also,
can you hear me?
my suggestion for you all
Yes,
is
sir.
to focus on
I'm hearing a lot of noise here. Someone's on another phone. If you can mute, thank you so much.
Yeah.
Yeah.
I thought he was answering your question. Sorry.
even I thought the same in the first part, but I think he's not. Does that, if somebody is saying data engineer, somebody is saying data scientist, so are you saying that the engineer who are building the applications do not care about data, or should it focus on data modeling?
So I think everyone who deals with the data should know data modeling.
Absolutely, exactly. Be it a business consultant, a data consultant, be it a software engineer, be it a data scientist, be it a data engineer, everyone who deals with data should focus on learning data modeling, right? And if you see as well, like today when you talk to, I mean, if you have seen many of the senior folks in the organization, right, be it the vice presidents or the senior VPs, or at that level, at a senior management level, typically, right, they know by the thumb of the hand, typically they know the particular data models essentially, because they have gone through the particular process essentially, right? Okay. Now, heard about a relational database, relational models, right? Basically, you organize into data into tables, relations of columns and rows. You have a unique row of identifying each row, right? Typically, one table represents one entity. Let's say you have a customer table, you have a product table, etc. Right? Any of the, and SQL is basically the language used to query this particular relation database essentially, right? For querying as well as maintenance. That I think we all understand, right? Common types of relational database which you have worked on or you have used for teaching purpose. Relational database. Common types of RDBMS which you have used for your work, for your teaching, etc.
Generally, Oracle we have used.
Okay.
And
SQL, MySQL.
MySQL, Oracle, right? And by the way, Oracle I don't think is open source, right? It's enterprise version, if I'm not wrong. MySQL has 2 variants, open source as well as enterprise version as well, typically. One more you can think of using when you are doing next time, like it's called MariaDB, if you've heard about it. MARIA, MariaDB, which is basically an open source fork from the MySQL. They do not have any licenses, nothing as such, right? You can use that thing, and the same query, the same syntax of SQL, which works for MySQL will work for MariaDB as well. Okay. I'll just put in the chat as well, so you get the spelling correct. Yeah, MariaDB. That's right. Yeah, Prachiti, I think mentioned MariaDB. Okay, perfect. So you have data as well. You have Postgres and SQLite and all those things as well, right? So that is there. So this basics, I think you are already covered with. Just a quick way through about it. Is that tables and relations typically, right? You have a customer over here, right? A group of rows sharing the same labeled elements, right? Employee database, employee table, department table. The schema is basically nothing but a collection of tables typically, right? Columns and attributes you would know, the very basic, right? So tell me something, a quick quiz over here. What is RDBMS? Relational Database Management System, right? And typically a schema is a collection of tables in some database terminology. Is it correct? Question, the other question over here.
False, sir.
Is it?
Yes, sir.
I think it's true.
Schema is a collection of schema means structure, na? So collection of tables.
In
A collection
some
of tables
DB,
mean database, na?
no, that's fine, but eventually you're having a database schema. That's what you typically call, right? And typically, and I'm not saying all database terminology typically, right? But some database terminology, they use the word of that. If you have a collection of tables, it forms a database schema. Okay. Okay. What about data warehouses? Any idea of data warehouses? Any clue on that data warehouse? We can store and manage data, very broad, Ruchiti, but point noted. Historical data, correct. Not transactional in nature, isn't it, right? Not about, me doing a billing system on daily basis retail perspective. So let's talk about raw data, large historical data, raw data. Yes, but let's see the questions over here, right? Storage of large
Management should monitor the sales growth.
Sorry?
Management should be able to monitor the sales growth.
Correct.
That should.
No, it's not a question, right? I'm talking just business activities. That's all. Not a question. Increase happening. The customer. So we have some business activities typically, right? So customer should be able to find goods and make orders. Inventory staff should be able to stock and retrieve and reorder goods. Delivery staff should be able to pick up and deliver goods. HR should be able to access the performance of the staff. So this is a retailer's data infrastructure, right? And there are a lot of, I'm mentioning probably 5 or 6 of them, but there can be a lot of business activities over there as well. And marketing team can do. So they all are having their specific focused business activity, right, in their domain. In the retailer infrastructure is concerned, right? Can I build a database to support these activities, right? Right? Are all of the above questions or these activities same nature? Maybe not, isn't it? Retailer has a nationwide presence, isn't it? So it is a scale, it has to be scaled enough, right? Acquired the smaller retailers, right? Brick and mortar shop, online stores. So single database, complexity will bring over here essentially, right? So has support for call center and social media accounts. Tablet data may not be helpful. Customers, inventory staff, and delivery staff expect the system to be fast and stable. Has to be performance oriented. The HR and the marketing and the sales reports want a lot of information, but have not decided yet on everything on the scope is concerned, right? So managing one single relational database probably won't suffice, right? So what happens over here, right? That is where these analytical processes come into picture. Operational means what? Transactional data, right? You're buying something, you're being billed over there, you're ordering something, you're adding entries over there. It is transactional in nature. It is operational in nature. It can never ever supposed to go down. That's operational. The businesses will be hit tremendously on a day-to-day work if the operational data, if the operational processes goes down. Find goods and make orders, basically, right? Essentially, okay. Uh, Basically, stock and find goods for inventory stuff. Pick up and deliver goods. These are more in terms of operational in nature. Can somebody please go on mute? I hear a lot of echo. Thank you so much. These are more operational in nature versus analytical. See the effect of. Is it just me hearing that echo, or somebody else is hearing the same thing as well?
No, I have muted.
Sir, we are here.
Acha, thank you. I know. I'm just checking, Guru. It is my issue on the network, or if I'm hearing the echo. That's all. Okay. Uh, Assessing the process performance of sales staff for HR, analytical nature. Monitoring the sales growth for management, analytical in nature. Right. See the effect of different sales channel for marketing. Right. You have channel partners. You have digital marketing. You have brick and mortar shop, etc., etc. So slightly what you see over here, we are trying to distribute or distinguish the business typical activities of operational process versus analytical process over here, right? In that particular segment over here. So similar to that particular thing, right? Operational databases, excellent for operation, right? No redundancy, high integrity, definitely. But they are too stiff for analytics. There are too many joins over there, right? Too hard to understand, right? So basically, analytical data typically, right, would essentially mean something which is aggregated, right? So data warehouse essentially is a system which includes processes, technologies, and data representation that enables to support the analytical processes concept. Okay, so that means what? That means something like this, right? You have the operation data coming in every day and every second, every minute, right? And they are being kind of aggregated, right? And those aggregated data can be used for analytical purposes. So OLTP, you've heard about, it's called online transactional processing, which is mainly used for MS SQL servers typically, right? Where you use it for operational purpose. The aggregation level on top of the particular OLTP, which is for analytical purposes, how well am I doing, which sales I'm doing well, which product is doing well over a period of time, which is time specific, maybe something at a point of time can also happen as well, are called as OLAP, online analytical processing, right? Some examples: need to track the inventory, operational process; track financial transactions, operational in nature; split the customers into market segments for market optimizations, analytical in nature; examining the market segmentation, for example, over a period of time, analytical in nature; split the customers into market segments, analytical in nature, right? So not operational in nature, but more of analytical in nature. So what do we understand? Analytical is more data which is aggregate over a period of time. Operational is always we have data more of transactional in nature, right? A quick quiz over here for you. What happens if we use the same database for both OLAP and OLTP? Any guesses? What happens if we use the same database for both analytical purpose and transactional purpose?
Sir, analytics keeps on changing.
Right. So which option will be answered here? If I use the same database, right, for both analytical purpose, over here can be multiple options, by the way. The schema will be hard to understand for business analyst. Yes, it will be. Because that schema will be now used even for analytical purposes by business analyst as well. Option one is also correct. Option 2 is also correct. The analytical queries will be very slow because you power a lot of joins over there, right? Database schema will be easy to understand. No, the third option not out of question. Will run faster. No, so A and B, I'm 100% sure is the answer. Also, it might be totally okay, and this is for very, very small data size typically, if you are having the analytical and the transactional in the same database as well for very, very small data essentially. So 1, 2, and 4, right? Perfect, Krishna. Exactly. What is a data warehouse? It is optimized to support process of data analysis. Yes, correct. Is it designed for OLTP? No, it is not. A data warehouse has data generated from or gathered from multiple sources. Absolutely correct. A database basically is a OLAP system or online analytical processing system. Basically, for the next question, there is 1, 3, and 4. All three options. Any questions here? A, C, and D. Correct, Vishaka. Correct. Correct, Neeraj. Okay. Fine. Guru, can you take a quick 5-minute break, probably?
Yes, sir. Sure. We can take a quick break. Right now we
Sure.
are at 250, 256 at 255 at my watch. We can join back at the 310 maybe.
Yeah.
335 or 310.
Yeah. I think I'll take the majority. Majority of the folks maybe 3 or 5 approximately, or 3 or 10. Which one do you prefer? I mean, it's been quite a good amount of thing going on. So I want to have your brains to calm down as well. So that's what. 10 minutes break. 3:10 is okay. Okay.
Yeah,
Perfect.
310. 310.
Perfect. Perfect. Thank you so much. Yeah. Okay. Right. So we were discussing about data warehouse. Let me share my screen. Right. Okay. Uh, so, in terms of data warehouse, it's simple to understand. It's performance centric also as well. If you have aggregate data, right? And quality assured is there as well. It can handle new questions as well, because you are aggregating data at different columns or different attributes, right? So we know how this works to an extent, right? From the days, it is not a new technology at all, right? It's facts and tables comes into picture. Fact table comes into the picture. We have dimension tables, context of business event. You have recording business event like order or a phone call. Those kind of things, right? Now, I don't want to go into those part of which has been their leg system already, right? Now, how the things are moving essentially, right? That is where these things come into picture nowadays. The so-called big data, right, is basically an overall term with no really single definition, right? It's easier to use a distributed system of multiple computers with dozens and hundreds of from an, let's say, Amazon data center, for example, instead of working on your own machine, right? So now, why do you think, right, in terms of the kind of data we are generating today, um, be it your transactional data, be it user data, be it your social platform data, be it your mobile data, right? We are generating at a huge and fast pace. Now, what has happened over here? Over a period of time, the generation of data has been extremely huge, right? At the same time, what has happened essentially is that the hardware capabilities, right, of our systems, which we typically, we used to have this, still we have in engineering colleges, the computer organization structure, right, the subject, right, the capabilities of the storage, right, The network bandwidth capabilities, the storage capabilities has increased. The data has increased. The storage capability has increased a lot. Network bandwidth capability has increased a lot. And most importantly, the cost of storing all those things at a very, very low cost that cost has come down drastically. So essentially, the amount of data being generated, we are able to store it in a very elastic kind of fashion as well, right? It's a very, very low cost, essentially. Okay. So if you think about, history of the parallel computing systems, right? Each kind of node communicates with other nodes with messages, right? They have all their private memory. The key difference over here in parallel computing of systems is that all processors have access to the shared memory systems to exchange the information, right? That is a key difference in the kind of parallel computing, right? So distributed systems or distributed algorithms are originally referred to computer networks where individual computers were physically distributed with some geographical area and communicated within each other by message passing. In distributed computing, each node communicates, with other nodes with messages. They have all their private memory. But in parallel computing, right, what is happening is that every particular processor have access to the shared memory to exchange information, right? So if I ask you right now, which statements do you think are true, basically, right? Which are true? Distributed computing assumes that multiple CPUs are sharing a single source of memory. No, it is not true. Parallel computing is another way of distributed computing. No, it is not the particular case over there, right? Let me see the chat screen once quickly. In general, parallel computing implies your multiple CPUs share the same memory. Yes, it is correct. With distributed computing, each CPU, in fact, it's not only 4 and 5. If you see in Vishaka, 3, 4, and 5 all are true typically. Apart from 1 and 2, even 3 is also true. In general principle, parallel computing implies that multiple CPUs share the same access memory, or they share the same memory essentially, right? So even also the case of in distributed computing, each computer machine is connected to other machines across a network as well, right? Okay. Now, how many have you heard about Hadoop systems or the Hadoop ecosystem? And what are your thoughts on that thing? Heard about Hadoop systems? Yep. So parallel distributed computing platform, correct? It is a framework essentially. It's called platform as well. It's a framework, right? It's an ecosystem typically, which consists of multiple tools for big data storage and data analysis, right? Hadoop has been the Apache Hadoop has been one of the primarily or very early stages where it started this whole concept of distributed parallel computing systems or framework or platform or an ecosystem as such, right? Hadoop typically writes when you have, I mean, Hadoop has four major components, right? One is the part of data storage is considered HDFS systems, the map reduce for data processing. It has a resource manager to, configure your resources, it manages over there essentially. And it has some utilities as well, right? One of the, I would not say con, but if you compare with Spark, right, typically the Hadoop system, right? As Hadoop matured a lot, right, over a period of time, the tools in the utilities section typically had also have Apache Pig and Apache Hive as well, right? That is kind of an SQL-like language that runs on top of the Hadoop MapReduce. MapReduce is basically for data processing systems. Hive again is used another SQL-like interface that runs on the Apache, Hadoop MapReduce, right? So essentially, if you see in general terms, when people talk about Hadoop systems, right, they generally talk about the MapReduce, right? But Hadoop is much more. It has HDFS, it has a yarn manager, the configuration manager, it has the MapReduce, it has this utilities of system, it has Apache Pig, Apache Hive. to run on the particular MapReduce system is concerned, right? Now, one of the problems is that whenever data is being kind of streamed across, is being processed, right? When data is being stored, right, the intermediate results, right, when you're processing huge chunks of data at a very, very fast speed, right? Hadoop is, writes these intermediate results when they're processing the data, right, to the disk in the HDFS systems, actually, right? Whereas Spark, another big data framework, right, it stores these results typically in the memory, right? Now, Spark typically does not have a or include a inherent file storage system, right? You can use Spark on HDFS as well, right? But Spark can read in data and write it as well from other, like let's say Amazon S3, buckets, Kafka systems, Redis systems, Elasticsearch. It can talk to multiple systems essentially, right? At the same time, Spark also has a very inherent capability of writing and reading data from the Spark memory itself, which makes the Spark framework comparatively faster when we process data typically at a much basically faster pace essentially, right? So these systems essentially, right, are being used today where so-called distributed parallel computing of data, streaming of data, processing of data has been fantastically fast, right? A Spark, I have used Spark in a lot of places in my career and my applications or my design, in my coding, in my architecture perspective. And we have got the benefits of using Spark where data can be processed. We had processed data of around 70,000 per minute. We had files coming in essentially at that staggering pace. And Spark was to do the processing without any hiccups essentially, right? So using the Spark capabilities, using the capabilities of memory writing and memory reading, right? Using the capabilities of semi-structured data in Spark as well, we were able to process data as real time as possible, right? Okay. So obviously, I mean, Spark again has some limitation as well, typically, right? I mean, we'll talk about it, right? Spark streaming has a latency as well. Uh, it operates on micro batches, kind of distributes the data into different kind of workers from the master, right? Also, Spark also provides a lot of, it's called Spark ML lib, Spark machine learning lib. It has a lot of machine learning algorithms typically, which and libraries which you can use. So you process data, keep on processing, you end days over, then you apply your ML libs over there. Spark has a lot of pretty good ML algorithms available as in-house in Spark, right? Comes often with Spark. And at the same time, not only that, it provide, think about you're doing a batch kind of process, right? Essentially you are doing a Spark data processing, right? And you can use this ML as kind of a batch deployment of your models essentially, and these ML libs can be used very effectively. So Spark, although Hadoop is used widely, but the kind of utility Spark is providing, what we see in industry for any kind of high end processing of data, scalable architecture, Spark is tops most of the particular architecture compared to Hadoop systems. And at the same time, whenever we have data down the line, for processing, usage of this library in the machine learning world makes Spark much easier to use compared to other systems. Can somebody go mute, please, Guru? Yeah. Okay.
Yes, sir. Yes, muted.
Yeah. Thank you. Okay. Any questions here till now? I mean, are you able to now understand that from the so-called legacies in way the data is being stored versus how data is now being handled in these parallel distributed computing systems versus what was there in the earlier days? Any thoughts here?
Sir, can I ask one question?
Sure.
Yes. So you told about the MapReduce and the Spark. So before few days, I have read about the MapReduce as well as the Spark. So is it possible to completely replace the that is Spark, MapReduce by Spark?
Absolutely, it can be done. See, essentially, what is MapReduce? Is basically a programming technique for manipulating large data sets. Correct. Now, Hadoop MapReduce is basically a specific implementation of this programming technique. And typically, if you think about it, how MapReduce works, right? It basically works by dividing up a large data set and distributing the data across a cluster. In a map step, each data is analyzed and converted into a new kind of a key value pair. Then these key value pairs are shuffled across the clusters so that all the keys are on the same machine, right? And in the reduce step, the values with the same keys are combined together, right? Uh, while Spark does not implement MapReduce, you can write Spark programs that behave in a similar way to the MapReduce program. Okay.
Okay.
Okay. Fine. Okay, so we had plans of these data handling, and the reason I took about that data modeling part, data warehouse part, was because that will give you a picture where things have been and where things are moving in the next gen platforms typically, right? And we also talked about the data science in the industry, what kind of scope they are. Slowly now we're trying to move into introduction part of small things, which we will deep down again. Data visualization, right? How many of you have seen the earlier days of BI and reporting? What have you seen typically in BI and reporting?
Dashboards,
And what in the dashboards?
graphs, bar charts.
Bar charts, histograms,
Yes.
All
ranking,
types of
Pie chart.
charts.
pie charts,
Chart.
donuts, right? Have you seen, I mean, if you're using Excel, let's not go into any very mature. I feel Excel is a very matured, tool for even for graphs as well, for visualization concerned, right? Have you seen the differences of charts? Scatter plot, yes, Archana, scatter plot, charts, plots, yeah. Have you seen the differences or the maturity of charts having in Excel today compared to what Excel was 3 years back? Have you seen that? And if yes, what have you seen the differences? 3D, okay, agreed. And the kind of charts, right? I mean, have you seen tree maps in Excel? Have you seen variety? Yeah. Have you seen the variety? I mean, the library of charts has been increasing, right? And this has been the one of the key inputs from the perspective of that the way you are visualizing data, since the amount of data has increased, since the data variety has increased, so volume and variety typically, the existing charts will no longer be used and be effective, rather, I should say, to portray your story from the charts itself. Hence, the variety of charts, of visuals, the variety of graphs has actually increased a lot. You would see graphs called as tree maps. You will see graphs called as chord diagrams. You will see graphs called as sunburst. A multiple of variety of that particular thing has come to picture, right? Now, why do you think we require visualization? I mean, why do you think this kind of change when you're exploring data, when you're understanding data? Why do you think? I mean, we were happy with the BI and reportings essentially, right? We were happy with the dashboards part essentially, right? But why do you think this has changed over a period of time? What was the need behind it? Any clue? Any thoughts? Data is very complex to extract, easy understanding, more expressive information for communication to take decisions. Agreed, absolutely. But the whole point is simplified consumption of data for better decision making, right? If I put in very simple words, right? Simplified consumption of data for better decision making, right? Having said that, how data varies with each parameter, correlation, correct, Shama, how they are, related, correlated, how they are, we call the univariates, the bivariates, we call it multivariates, hundreds of things over there, right? And how they are kind of, and more importantly, what is the relation coming in, what is the story coming out, right? Now, visualization is a very, very important topic today. And not only visualization, but it is called typically storytelling with data, right? And that's one of the very, very hot topics in the market, very hot topics. And it is still in a very mature, in progress maturity stage. It is evolving and people are making sense. And you have probably heard about, I don't know, Tableau, or you have heard about ClickSense or Power BI. Apart from the Excels of the world, right? They use a lot of these capabilities of storytelling, right? And using visualized storytelling and to figure out the different aspects of data, essentially, right? Now, if I tell you that right now is to analyze the data, correct with the absolutely. Now let's see. We are talking a lot. Let's say we'll have a quick quiz right now. Okay. What we will do right now is that we'll do a challenge with all of you. Right. You don't necessarily have to shout the answers. Don't do that. Which one is open source tool, Dr. Gauri? D3 is open source tool. Let me write that thing. D3 is a JavaScript web-based thing, D3. In Python, you have heard of Matplotlib, Seaborn. These are of course parts of the thing. Tableau, you can use Tableau. There's a public version, which is basically open source. Okay. Power BI, you can use it, but you can save it over there. But Power BI, if you want to collaborate your graphs on the Power BI cloud, you can't do that. But you can use Power BI free of cost on your desktop, right? Scalar vector graphics, SVG. I think you're talking about tool, Shama, or is it some kind of, because SVG is a format typically, right? SVG, scalar vector graphics. Right. Okay. Yeah, that's a format. Got it. Right. So now we'll have a quick challenge. Don't, you can probably note it down probably, and in your chat box, don't shout the numbers right now. And then we'll see the solution and how it works. So let me, so you'll have 3 questions over here, right? And what will you do is that you'll have 10 seconds per questions, 3 questions, 30 seconds, right? And we'll see what is your answer. How many numbers are above 100? Put the chat on your, put the answer on your chat. Time over. How many numbers are below 10? Which quadrant has the highest total? You don't have an 8th quadrant, Yogesh. You have 4 quadrants. Okay, fine. Right. Now, probably can unmute yourself, right? So what were your answers? How many numbers were above 100? Probably unmute yourself.
Three.
Others?
3.
Somebody said 4.
4.
As well.
4.
4.
It was 4. 4.
4.
Was it 4? Okay. So within this small number of folks we have today, right, we are also having variety of answers, right? And obviously there will be some correct and incorrect, absolutely, which is fine. But let's say answer this question with simple visual cues and how long it takes, right? Numbers above 100, 6 of them, 101, 107, 104, 102, 101, and 103. Correct? It took me how many seconds? Probably 3 seconds to answer the question. How many is below 10? 7 of them.
7.
Correct? 8, 3, 5, 7, 2, 6, 9. Correct? Took how many answers? Seconds? 3 to 4 seconds. Highest quadrant, the fourth quadrant. Right? So first, second, third, and fourth is the fourth quadrant typically, right? Okay. So what we are seeing here, what is the difference we see? Everybody had their own set of answers, right? Some matched the answer with the correct one, some had different answers. It's not about only the speed at which you're answering the question, right? It's also about the correctness of the questions, of the answers, right? Believe me, senior management folks in the industry, CXO level, senior management, they won't even look into your graph or your visualization from more than 10 seconds, not even 10 seconds, right? They want to get their answers very, very fast and correctly so. That means that visualizations, visual cues, colors. In fact, if you think about it, we human beings, right, have been, you know, looking into particular the text particular part, right, and numbers many years back, right? But we understand colors much better compared to numbers or even text essentially. Right? Visualization helps in telling you analysis of the data, helps you tells into exploration of data in a much fast manner. And give me a moment here. One sec. Yeah, sorry that my son was here. Sorry. Okay, so the context here is visualization typically helps in telling or conveying your stories better, correctly, fast manner, helps in your decision making process. Another very good example here, right? You see over here 4 cities mentioned over here, right? This is a sales report of 4 cities, their branches in their 4 cities: Boston, Chicago, Detroit, and New York. And each branch changes the product price every month, which leads to a corresponding change in the sales as well, right? And this is the monthly number of one particular year of Jan to November. Now, if you see these numbers coming over here, right, what do you see over here? We see that the average price of Boston, Chicago, Detroit, and New York are identical. The variance identical, typical, right? So what is coming over here is that the variance and the average of both the price and the sales look similar, isn't it? Correct? From the tabular data? Agreed? Everyone?
Yes.
Over here 9, 10, 7.5, 10, 9, 10, 7.5, 3.75, 9, 10, 7.75 for every city over here, right? Slightly if we change into visualization, it gives a different story altogether. It changes the story completely, right? Boston sales has generally increased with price. Detroit has a nearly perfect increase in sales with price, except for one aberration or one outlier. Chicago shows a decline in sales beyond a price of 10. And New York sales fluctuates despite a nearly constant price. Very simple, or the simplest of graphs we are showing over here. It's just a scatter plot essentially, correct? Between two variables. That itself changes the story from here to here. Got it? Agreed? Making sense right now? So those variances, those averages of price and sales, which were shown in tabular data, which were not giving the right picture, a simple graph is giving the different picture altogether, the same data points. So that means storytelling with visualization is extremely critical. You can do whatever models you want to do. You can use the finest of deep learning models and machine learning models. If your story of your model is not being conveyed properly, it will not be impacting the business stakeholders. It will not be helping to improve the business stakeholders' consumption. They will not be taking your machine learning projects to the next level. So telling stories of your ML models, or even the simplest of descriptive analytics as well, right? If you do not do that properly, it, your whole project, your whole effort, your whole time being put across over there will go for a toss. Visualization is that piece, or storytelling is that particular thing. It's a last mile typically in, and not only last mile, even today when you're working on data science, right? I mean, the core is data, isn't it? There's a topic which we'll discuss tomorrow. It's called EDA, exploratory data analysis, right? And if you're analyzing data, right, and if you're understanding the pattern of data itself as it is, visualization is a key over there, right? It helps you to understand the analysis of data as well. Any question here? Any thoughts? I can hear a drum banging in the background. Any thoughts here? Any questions here?
Excuse me, sir.
Yeah, go ahead.
Yeah, I have one question.
Sure.
Yeah, so data visualization actually that should be learned after learning the concepts of machine learning, or it should be taught earlier how to visualize data, how to
There
see a
is
better
no
picture of
correlation.
data.
There is no correlation in that point, right? There is no hard dependency that only when you learn machine learning, then you have to learn visualization, or you learn visualization, learn machine. No, they are two independent tracks altogether, right? They definitely culminate together at one place, right? But that doesn't stop one from learning one before the other or one after the other.
Okay.
Okay.
Okay. Thank you.
Okay. Give me a moment here. One sec. Okay. Now, tell me something. I mean, the visualization concept, we are banging our drums and saying that, we have a huge maturity of graphs, huge data coming in, huge amount of analysis has to be done. Hence, visualization and storytelling, all big words. Yeah, absolutely. It is true. But the reality is, visualization itself is not a new thing. Okay. So, I mean, why I'm saying that is because if you see this visualization over here, right? This was something which is a visualization being taken in the war in the 21st of century, right? And this was taken by Florence Nightingale, right? When there was a war between England and France, right? What she was able to understand over there is that there are a lot of people dying because there was not enough hospitals or enough healthcare centers built in England typically, right? So now to build those particular healthcare centers and hospitals over there, right? They needed particular funds over there essentially, right? And that is where she created this visualization around the 21st of century, right? And what came out over there, right, in those visualization was that basically if you see over here on the right hand picture over here, right, and many people had tried obtaining funds for hospitals, but most of the budget has been wasted to the war effort, right? The visual shows over here basically month on month, if you see, right, and the number of people that died for the war effort. The red particular part over here are the people who died out of war wounds. In black over here, if you see the number of people that died from other war related causes, and this is actually blue in color, which tells very clearly who died or the number of people died due to avoidable hospital diseases. So essentially, a war is won by people, and the main reason England was losing people wasn't bullets or swords, but diseases. So Florence Nightingale in the mid 19th century, not 21st, but 19th century, used this visualization to request for the funding for the hospitals, and she eventually got it. And eventually, England won the war in the mid 19th century. So a visualizations concept is nothing new. It has been there for a long, long time typically, right, as well. Another very good example, a very classic example, right? This is actually, you can see it's a which city you're talking about. Any idea which city? From the street names, any guesses, wild guesses? This is which city? Map. Any guesses?
London City, I think, sir.
Correct. London City, right? So this is again in 1854. Think about it. We're talking about visualizations and the sunburst and the different kind of charts. This was built in 1854 when London was suffering from cholera epidemic, right? The popular theory at that time was that the cholera was caused by pollution. That was the popular theory at that time. Dr. John Snow was skeptical about this thing, right? And by talking to local residents, he identified the source of the outbreak, right? This is basically Broad Street, if you see, one of the very popular streets in London. He identified the source of the outbreak, this public water on Broad Street. Dr. Snow used this map to illustrate the clusters of cholera around the pump areas typically, right? Today we talk about clusters, right? Today we talk about clusters, unsupervised learnings, segmentations, market basket analysis, etc., etc. A very, very small representation of data, right? In terms of to show the outbreak of the cholera in different clusters in London around the pump areas. He also used statistics, right, to illustrate the connection or the correlation between the quality of the water source and the cholera cases as well, right? The visual itself was so convincing enough to persuade the local council to eventually disable the well pump by removing its handle, right? And it's still kind of regarded as one of the founding event of the science of epidemiology, right? So these visualizations are created long, many years back, right? It's not about big data itself. So visualization itself has a power of telling stories, right? Provided you weave the story correctly to make necessary impact, right? One more very interesting example, right? Any idea? This is again a map of London, right? Any idea? This is used. What is being used over here to draw the particular map? Any guesses? What is being used here to draw the map?
Traffic density.
Traffic density. Close. but not exactly that thing, but very close. Uh, every dot, basically, this particular whole map itself is using data to draw the particular map. Okay, now every dot is basically a photograph on Flickr. If you remember, Flickr was there once, right? Long time back. Now we don't use Flickr that much. Every dot is a photograph on Flickr taken at that location. The red dots typically are the taken by tourists. The blue dots are the photos taken by locals. So we know who the tourists are by checking where the majority typically of the photos in London are area or not. So you see over here in this particular thing itself, right? We can see the structure of the Buckingham, the whole city itself, the roads, the particular river Thames over here as well, popular areas like the Tower of London, the Buckingham Palace over here is coming over here as well, the Westminster Abbey in red, and the popular business districts are in blue essentially. You look at these areas, right? This despite today you use Google Maps then and there, right? Despite not using any underlying map, right? There is nothing here on this image other than just millions of data points from Flickr, right? Again, a very, very different kind of visualization, right? But, you know, to help to understand the fact that how you can visualize the whole city, where my locals go, where my tourists go, and how the structures, the popular places would emerge from visualization automatically, right? Very interesting one. Some of the things I want to discuss, I won't take all of them, right? We'll see this one, a very interesting visualization, right? Any idea what we're talking about over here? I'm 100% sure you can guess it correctly.
Menu of the
This is
hotel.
correlation.
Agreed. Fantastic correlation. And that's written over there on the title. I can see that thing. Absolutely. But it's a heat map. Absolutely. It's a heat map correlation. Heat map is the medium or the chart to display the particular correlation, right? Essentially. Now, when you look at the correlations, you see on the right hand side over here, right? You say Rava dosa, pav bhaji, onion dosa, masala dosa, multiple things. Basically, it's a restaurant's product they're giving. What's happening over here is that if you see this thing, food items, you have idli, you have curd vada, you have vada, plain dosa, and all these things, right? What you see over here is when you look at the correlations, right, at an individual item level, typically, right? And the green means they have a high correlation, red means they have a negative correlation, essentially, right? It turns out that there is one product that is negatively correlated with almost every other product. And which one is that? There is one product which is negatively correlated with almost every product. These are my products over here. Red means negatively correlated and green means positively correlated. Which product over here is negatively correlated over here with every other product? Quickly. This guy, isn't it? This guy is almost red over here. Means basically with curd rice, it's negative correlated. Coffee, negative correlated. Tea, negative correlated. Bisabala bhat, negative correlated. So basically, this 1 liter mineral water bottle is negatively correlated. That means the sales of 1 liter bottle is negatively correlated with almost every product. Why is that happening? Right? And this visualization is telling you the what part, not the why part, essentially, right? So that means whenever people are buying the bottle of 1 liter mineral water, right, they are not mostly buying the other products typically. That is the, you know, the pattern coming out very, very clearly, right? This is a curious phenomenon, right? And when our client explained this, once they realized what was happening, right? It's a low end chain of restaurant, right? essentially. And it's mostly individuals and not families that visit the restaurant. Their customers are rather price conscious. When they buy the 1 liter bottle of water, they want to make sure that they do not waste it. And when the entire liter is consumed, there is not space in the tummy, in the stomach for other things, right? So that was a root cause of why this mineral water bottle typically was a negative correlate of the sales with the other products, right? So in that case, we found what was happening with this visualization very quickly. We understood the fact, after talking to the business, the restaurant folks over there, what was the problem, and rather, why was the problem. And you know what the solution was? The obvious solution over here was that to replace that particular 1 liter bottle packaging with 300, with the 200 ml of sachets or water bottles, small water bottles. This ends up turning the entire row, this red row, into columns of neutral yellows, and resulting in an overall increase in the sale of products. That is where these visualizations can be a trigger point of your business impact is concerned. Clear, everyone?
Yes, sir.
So, I mean, that means apart from you, nobody else is clear, is it? Okay. One more very interesting example from the same particular thing, right? I mean, same uh, restaurant decisions. I mean, I'm giving you industry case and how visualization helps over here. We're not talking about tableaus, but we're talking about the visualization itself, right? Just like we have a heat map, we talk about here a calendar heat map. Okay. Very interesting. Same chain, right? And we looked at the daily sales across restaurant. They have uh, four point of sales over here, right? What does it tell you over here? It's basically sales one, sales two, sales. I mean, in that particular way, right? And we looked at the daily sales across the restaurants. There's a series of calendar maps which shows the daily sales for 4 different point of sales terminals at one restaurant, right? Point of sales, a same restaurant, right? Each calendar map typically over here shows what? It shows a calendar of 7 months, right? Each day over here is colored based on the value of sales on that day. So red indicates low sales, green indicates high sales. Quickly, I understand over here. The moment I say green, you say it's good. And that's how human minds grasp colors easily. Had I told you, okay, not only sales, it's also profit. So I would say green, that's a good profit. Red, losses. Neutral, in between losses and profits, right? That's how you grasp colors better than text or numbers. Okay. Now, what do we see over here? For the two terminals, basically, at the front, right? If you see over here, sales was relatively less. We see that month of December and January until mid of February typically was less in the first 2 months, but picked up steadily thereafter. From mid-February, it picked up from yellow to green, and March, April, May, June went pretty well, with except some few exceptions on the days, right? It's easy to spot the exception among this. For example, let's say the 30th, typically if you see over here, right? The 30th and 31st, right? Among these bad sales days, January were good days for both these terminals. We'll come to the reason later why it happened like that. But we can see that 30th, 31st of Jan, for both these two counters, it happened pretty well amongst the badder days of bad sales, the sales, right? Now, the other one over here is that, interestingly, when you look at the terminal at the bottom left, this particular guy over here, right? There is a red bar. If you see this red bar over here, continuously on Wednesdays, right? That means it's an indicating a consistent dip of sales in that restaurant, right? Every Wednesday, almost as if to compensate the terminal at the bottom right to increase the sales every day. You see over here, this is one point of sales. This is one point of sales, right? This visualization tells me continuous dip across the so number of, I mean, in fact, this particular point of sales point over here, what happened over there, that although these guys, December, Jan, and February went bad, for him, for this point of sales, December went pretty well. except for Wednesdays across all the particular months, right? What's happening here is that at the same time, the same Wednesday over here, if you see in this part, is actually doing better compared to the other days, right? So as if this guy is kind of doing a composition over here. We did not have, again, we got the what part over here, right? We didn't have an explanation, right? Though our client did a few weeks later, it turned out that the person managing this point of sales counter takes a half day off every Wednesday and was not being replaced by the manager. The queue from this counter would shift to this particular counter, increasing the sales over there. But this restaurant is an area where there are too many other food outlets. So once the queue reaches a certain size, people drop off, resulting in a net loss in sales every Wednesday, a sale, a loss that has been unobserved for 7 months at least. Right? So you see here, how can visualization bring an impact on your business by, very simplest stuff. And I mean, had not been we creating these kind of visualizations essentially, right, and these kind of maps, it would have been very hard, right, for people to find out what kind of patterns I'm able to observe or not observe essentially, right? Any questions here? Are you able to make a, understand the, uh, the
Yes, sir.
the
Yeah.
visualization, right? That is more important for
Yes,
me.
yes. Sir, what is written on the left side? If you observe the first chart, 48, 48, 47, 48, is it the number of Mondays, number of Tuesdays?
No, 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 no. That particular thing, if I'm not wrong, right, is basically the average over here essentially, right? So basically in this particular day on Wednesdays across all the Wednesdays over here, across all the particular months, is basically the particular average of sales essentially.
Okay, that means the average of sales on Wednesday for the first chart is 47.
No, 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 no. The average of sales typically essentially over here, right? On Monday,
Okay.
across all the Mondays, across all the months over here, is around 48K essentially. Okay, like
Okay,
that.
okay.
About rather I should say for 40,000, right? In that particular way.
Okay.
These are my dates over here, as rightly mentioned, and the color terms the sales over here, right? So over here, if you see over here, not only in this particular thing, if you see over here as well, across these days, this particular week itself as well, right? This is a whole week. This is my average sale basically in that particular week itself, essentially. And what I can see is over here, the distribution at a weekly level over here as well, isn't it?
Okay.
Got it.
Okay, sir. One more question. Now, if I have a set of data, how would I select that which is the best visualization tool that I should use? Whether I should use a scatter plot or a histogram or what else should I use? How can I choose that?
Two things. There is a thing called chart picker, right? Let me see if I have the thing or not, right? Let me check this thing. One sec. I think I have it. Give me a moment here. One sec. I had one thing called chart curve. One sec. I'm just trying to get that thing out. This would be helpful. Yeah, got it. Yeah, let me share this thing to you right now. See, this is, again, there is, believe me, in industry, there is no thumb rule as such that if it is this, then it has to be this. But there can be a good starting point in order to you to, start that what chart should I pick, as you rightly mentioned, this can help you over here, right? For example, if you're doing some kind of comparison, right, and you say among items, for example, right, two variables per item, you can use a variable width column chart, or you're having basically one variable item, many categories, this kind of table or table with embedded charts, many items, probably a bar chart, few categories, few items, column chart, right? If you're having over a period of time, typically, right, cyclic data, those kind of things, essentially. Right. So I had somebody speaking in chat.
Okay, sir.
Okay. If you're doing, let's say, distribution typically, right?
Yeah.
Here, it's a single variable distribution. Few data points, many data points, and a histogram would go. If you're doing a few data points, a line histogram, typically a column, sorry, a column histogram will be helpful. So over two variables, typically continuous variables, the scatter plot is good. Three variables, 3D area chart kind of thing. Some kind of doing some kind of composition data is essentially changing over a period of time, few periods, realism may matter. You have a stat column chart like this little thing. This would be helpful in terms of what you would like to show across the variables over a period of time, one, multiple, etc. This would be a good starting point for you.
Okay, sir. Thank you.
In fact, I will share this thing right away. Okay, I think I can share it. Guru, I think we can share this over the Zoom as well, right? That will be helpful.
Yes, sir. Yes.
We can do that.
Through file, I think.
Yeah, I'm doing that only.
Yeah.
Yeah, I've just sent the file for everybody and have a look. You guys got the file, I guess?
Yes, sir. Yes.
Okay, perfect. Perfect. Okay. So this was what about the, okay, I need to share my screen, sorry. Okay. About the point of sales happening, right? A calendar map kind of thing, right? Which helps to understand the where things went wrong, right? And we talked about some of classic visualizations as well, right? Another very interesting part, right? Let me share you. I don't want to cover all the charts. It will be impossible for you. But some of the charts which I feel interesting typically. Let me show you this thing. Right, this one, very interesting. This one, right? This chart is typically called as Sankey. I'll write the name over here as well. Okay. It's called Sankey chart. Okay. So you see over here, right? This was about a use case or a case study about a cargo delay, right? It tells or it kind of measures the recovery time, the time from which the arrival of the flight until delivery. So you were having sending couriers and cargos, right, over flights. The company was dealing about the time, particularly how much time it takes on which days and essentially which times, right? Now, this recovery time, typically, you see over here, it's called a Sankey. It's more of operational based, right? What does it do over here is that it tells you that on what kind of day, on what kind of shift, typically on weekday, on which shift, on which product category over here, right? Am I doing well? So that means again, red is a bad, recovery time is bad, and yellow is okay. The green one is basically I'm doing fantastic on the recovery time, essentially. So I see over here that, specifically Friday mornings, if you see over here, right? Friday, the morning shift, I'm not doing well. The recovery times on the Fridays are extremely bad, right? And are kind of best on Saturdays typically and on Wednesdays, right? They are green in color. So basically in the actual scenario, what happens is basically something like this, right? When you click on this particular chart itself, it kind of dives down one by one like that, right? You see over here weekday, right? You see over here that, folks on the FH product category, for example, right, has the best recovery time. It's green in color, whereas ZDH typically has a worst, right? So however, RPP product category on Sundays is unusually low, right? And then you again further drill down, further go down over there and see, okay, fine, my Fridays are very bad. My ZDH product is not doing well at all, essentially, right? And what I'm seeing over here is that the part ship products tend to typically worse or perform worse than the full shipments, right? That means you're seeing like 40 to 60% and less than 20% shipments, which I'm doing, especially for ZDH product category over here, and especially on Fridays, is my specific area of concern. That means what? That means I am able to over here understand, if I do a deep dive slowly and gradually, that using this visualization for recovery time, I'll be able to do a deep dive and understand in which shift, on which weekday, for which product category, for which part shipment, I need to take an action. That means visualizations helping you to take a specific action for a specific category of product, specific weekday, etc., etc. Right? So this is again called a very matured visualization called Sankey. It helps you in terms of going to the root cause or going to root action item essentially. Okay. Another example over here, right? A very interesting example. Okay, this is, you will see in Excel as well today. In the Excel's parts of Excel, you will see as well, right? Is that you have a product being kind of sold across multiple countries. Okay, and you have a product being stored across different partners. It can be partners, it can be a direct product sale, store sales, multiple different partners, right? And you have multiple products being sold across in multiple channels essentially. Okay, now what this tells me, this visualization, is that it shows the market opportunities across the various countries to identify the areas of focus. It's a very interactive one typically. I mean, actually if you click over here, this particular thing itself, right, it will give you a different picture. Okay, now what is happening over here is that I am seeing again, a acceleration means grow more and more, cut down on the cost, it's a redder one, and yellow is kind of gearing up or building up essentially, right? I see over here the sunburst typically, when if it's an interactive mode, I could have shown better, is that you click on this thing, it will kind of burst only on China and it will show all the products of China typically, right? The way it is being shown over here is that I'm able to understand that US is doing decently well, though a less market share for this particular product itself, for this area itself, right? Market opportunities. I'm seeing UK is doing pretty well as well in terms of, right, they're green in nature. I'm seeing the direct particular the channels, right, of UK are not doing well, or rather the stores are not doing well typically, right? The size over here tells me the particular, the whole value itself, and the color tells me the particular, you need to accelerate or you need to build or you need to cut down essentially, right? And I see over here which product is not doing well in UK. I can well as click on the particular product itself essentially, and that product will now be shown across multiple regions, multiple channels across them, right? So it's basically hierarchical in nature. Hierarchy means what? One country, multiple partners, one partner, one particular channel, multiple products. So data is in a nature of hierarchical nature, which is being aggregated over here at different levels. So I can take a sweet spot over here at this level, drill it down and see how it's happening. Is it the product issue, or is it the channel issue? Is it the particular region issue, etc., etc., etc. This kind of chart is typically called as sunburst. I have the name over here as well for your benefit. It's called sunburst. Okay. And this one gives a good deal of understanding that at what you can drill down essentially. And this is very useful for, when you have less number of attributes. Basically, you have country or region, you have channels, and you have product. If you have too much of attributes, this chart may not be right at all, essentially. Okay. Another example typically, right, is very interesting one, 2004 elections. In 2004, who won the elections, guys? The Lok Sabha elections? Remember? 2004? Who won the Lok Sabha elections in India? In 2004, who won the Lok Sabha elections?
Congress.
Prajakta says BJP. Yeah, Congress it is, correct. BJP won from, I think, 2014, right, if I'm not wrong, correct? Is 2 into 11, if I'm not wrong, from 11. Yeah. 14 or 11, 11, 16, 16 and 21. Yeah, 14, correct. That's right, 14. In 2004, Congress won, right? And there are around 1,350 candidates approximately from 6 national parties: BJP, BSP, CPM, INC, RJD, SP, and they had their own alliances as well, right? And there were around 898, around 900 candidates from officially recognized parties and around 2,300 independent candidates as well. Now, we know Congress won, but if you see the map over here, obviously the blue one is Congress, as you can see, INC, and the red one is the BJPs, the NDAs. Now, obviously from this graph or this map, what does it tell me? Does it tell me that Congress has won? Or does it tell me the BJP has won? This map tells me BJP or Congress. This map, when you first see the map, you see obviously it's BJP, right? You see the more essentially, correct? But which is actually not the case. It is wrong because it is Congress who won the elections, correct? So, in fact, it was a kind of very close win. It was a close, the finish rather. Congress had 145 seats won and BJP 138. Very, very close, right? The constituency where each party won is shown here, right? What do you think is incorrect in this graph, in this visualization? There's something wrong, right? I mean, if the visualization is giving me an incorrect picture, then I'm doing something wrong in my visualization itself, or the data is 100% correct. No issue in that particular thing. But the visualization tells me that BJP won, but actually Congress won. So what I'm doing wrong over here?
I think we have to do the recoloring with the alliance party. Then I think perfect outcome we can get.
I don't think so, but good point, noted. What was happening over here is showing the constituency is wrong. The area of the particular state, right? If you have, let's say, if I take, let's say Rajasthan, for example, right? Versus a state area which is probably smaller than Rajasthan, let's say Jharkhand, for example, right? Maybe the number of constituencies typically in Rajasthan is equal to the number of constituencies in Jharkhand. Very much possible, right? That does not mean that my particular area of my state is proportional to the constituencies. Does not mean that only because the state area is bigger, right, doesn't mean you have a larger area one. At the end of the day, it is the number of constituencies you have one matters to over here. That means over here, the incorrect part over here was that you are showing this particular thing as if the whole area was one. So obviously Rajasthan is a much bigger area, of course, right? It's as if BJP has swept the elections in Rajasthan, right? It has won the constituencies. Maybe you have a similar number of constituencies in other areas as well, whose state area as such can be less than Rajasthan possibly, which is not here coming correctly. Getting the point? That means in this particular case, if I want to correct this graph, this one probably will be giving a better picture over here, right? In the previous page, BJP in red, which won considering large physical areas, Rajasthan, MP, appear to have swept the elections, right? That is typically, this kind of graph is typically called as choropleth, basically, right? It's called choropleth. pleth. Okay, and this graph is typically called as Darling cartogram, right? This one basically over here in this kind of thing, this cartogram is kind of resizes the constituencies proportional to the number of voters, and it's easier to see that at least Congress had, you know, as many seats almost as BJP, or more than seats, slightly more. But this one tells me that it was a very, very close finish compared to the earlier one, which showed me that as if, you know, the BJP has won the elections in 2004, but it's not, which was not the case over here, right? So this kind of, you know, so what, as somebody asked rightly, that what kind of charts I would choose. One is that what kind of charts you take and show. Also, the way the visuals are being depicted in the particular, you know, visualization, whether it's a map or something else, right? You need to make sure the data's story is coming out correctly. In both these cases, the data was correct, right? But the way I visualizing the data gave me a different picture. So one important funda here is that, again, from an industry perspective, what you are showing in the data, how you're showing the data perspective does not make you or does not pull you from making a wrong decision. That's very important, right? And another very, very important thing is that in terms of personas, right? I mean, you create visualizations, you create a lot of this thing, but it's very important that for who you are creating the visualizations, right? When I'm saying who, at what level the users are, the maturity of users typically, right? Think about it, you are creating a visualization probably at a level of, let's say, CXO level companies, right? So those visualizations will be very, very different at a level of people who are at a management level versus operation level versus analytical users level, right? Persona, who is consuming your data and its visualization is very, very critical. We take that as a homework typically when you do those particular things, that okay, the same metrics probably much aggregated at different level at a 50K feet level is for my CXO level. So they would not go to my, they will not drill down, they will not deep dive. They would see a problem happening over here and they would delegate the whole thing to the next level essentially. So that kind of aggregation of data is very critical in terms of to understand who is showing you what data over here essentially. Okay. Any questions here? Any thoughts, any questions, or any suggestions? Yeah, go ahead.
Yes. I think the numbers will speak better in this situation. So, is there any point to again visualize such kind of data in that case?
Numbers, absolutely. I mean, definitely. I mean, in fact, let me check. I think I have a portal which is there running. One sec. I mean, it's basically kind of, I'm giving you like visualization over here essentially, but definitely it's a combination of numbers as well as the graph, which helps you to understand the things better. I had one particular live thing. Let me check that once. Let me check that. One sec. Let me see that thing. let me find that out. I think I have one more example actually, where we had a culmination of numbers plus the graph from the elections perspective, and a lot of filters coming into picture. So let me find that thing out and then share that thing across with you. I'll share with Guru and he can share that thing across. Okay. But obviously, in this particular case, the intention was to help you understand that why this graph is incorrect and what is wrong and what we can do to improve the particular visualization. Essentially, that was the main reason behind it. Okay. Okay. Guru, one request. Can we take a 5 minute at mid at 4:30? I think we have 1 hour left. Start the introduction to ML. Maybe a 5 minute quick break and mid at 4:30. Do you go 4:30?
Yes, sir, sure.
I'll just have maybe a cup of coffee or tea and then.
Yeah, sure, sure.
Okay. Thank you.
Sir, you can start.
Okay. Okay. So till now we have been discussing about the broad overviews of data scientists in the current industry. We are talking about the different case studies of at a very broad level in the industry where we are surrounded by these ML outputs and AI outputs day in and day out. We're talking about also the different parts where you have problem understanding, where you are doing model building, etc., right? And also a brief introduction about visualizations as well, right? Where we see there is a huge need of how well you build the models, irrespective how well you tell the story, right, of whatever you have built. Storytelling is one aspect which is completely missed in the industry, and it is very hot. And somebody was asked that, do we need to learn machine learning and visualization? No, they are two different things, but they would be culminated. But it is not that you cannot learn visualization without learning machine learning. You can learn ML without visualization, but if you are learning ML, you need to learn visualization as well, because at the end of the day, you have to weave a story essentially. Now, in core machine learning, right? I mean, irrespective whatever data you're bringing in picture, whether it's structured data, that data which is data which is semi-structured in nature, which is be it in a financial domain, be it in a retail stuff, a CPG industry, be it in terms of social media industry, marketing industry domain, sales domain, irrespective, right? Generally, the steps involved in a machine learning solution remains almost the same at a broad level, right? And interestingly, what happens is that most of the time, typically, the data is, or the time which is being spent typically, right, is on the part of data collection and data cleaning, right? And it is a myth that you will learn a lot of models, you spend time of the, because the models which you build today, which are being implementing certain algorithms, be it linear regression, be it any kind of regression or classification techniques, or any supervise any clustering techniques, right? Those are, I mean, if you know what you have to do, those algorithms are there with you already. They are ready for you. There are libraries in Python called scikit-learn. Typically, I mean, in Spark, they have MLlib. But on what data you are doing the task, on what data kind of you're doing the task, on what features of the data you task, if that is in a bad shape of quality, right, that will be a huge problem essentially. Okay. Can somebody go on mute, please? Helpful. Right. So the first step of this whole ML solution life cycle, or data science as whole as such life cycle is concerned, is collection of data, right? Preparing the customer data from different sources, which are in silos, in different systems, aggregating them, accumulating them, assimilating in one place, one of daunting task typically, right? Then you have the problem of data normalization, right? I mean, data can in different scales as well, right? There are a lot of problems in data, which is one of the biggest challenge we see in data science and machine learning, is that missing data, right? Incomplete data, anomalies, outliers, right? You have to handle them essentially, right? So basically handling dirty data, handling noisy data, right? And this step of collection and normalization takes around 60% of the time of the overall life cycle of the project, right? The other thing, right? Once you have the same example in terms of, in fact, this is a wrong one. The feature engineering typically comes over here itself in normalization as well. After normalization, it comes into picture that you had, let's say, 10 attributes in a particular data, right? I mean, think an example. Let's say, let me ask you this. You are getting data about a shopping mall. So you're giving, you're given a job that uh, in which particular days I should have a good amount of workforce in my shopping mall to handle the footfalls. Right? So what you are given over there, you are given that on every particular day, let's say 1st March, 2nd March, 3rd March, like that, you're given the particular footfalls, right? So those are your existing attributes, correct? But tell me something, in that case or that scenario, does the date really matters for a shopping mall footfalls? You're given the job of, to understand that when can you put off more campaigns or promotions or put your more workforce into picture for handling more footfalls. And for that context, you're given across footfalls every date, right? So you're given 1st March, 2nd March every day, and you're given the number of footfalls in shopping mall. Is the date important here? Date and days. Yeah, go ahead.
Yeah, because maybe salary dates as well as festivals.
Exactly. So what is important is basically the day of the week and not the date. So basically, if you see over here, explicitly in the data, you're given the date, right? Implicitly, you have the day of the week, isn't it? So that means that is called feature engineering, that you are extracting or creating new columns or new attributes from the existing data itself. And there are tools who can do that as well. In Python, in AutoML, there are tools who tells you, and further they can tell you is that feature, how important they are, etc., etc. Right? So feature engineering comes after when the data is clean, you have handled your missing values. We'll talk about in details later tomorrow as well, that how do you handle those stuff? How do you handle missing values? How do you handle outliers? How do you handle incomplete data, etc., etc. After, when you have some kind of data which is in a matured shape, right, then you start creating the fact of that, okay, good, now what will I do? Now I will start creating new particular features from the existing data, like as I mentioned the example, from the date I create in terms of the day of the week essentially. Okay. And then would come the particular modeling perspective, right? You know that what you have to predict, what you have to forecast, or what you have to estimate based on your business use case. I would then start to use those important features, which is part of the feature engineering problem itself, important features, and start to predict the particular thing itself, right? And believe me, in the reality, we have all these algorithms in place. It's just the question of creating the training data and all those things and making sense out of it, right? So, and after you build a particular model, you start deploying the particular thing. It's a continuous process. You have iteratively been done, and you keep on monitoring the particular model's performance, and then tweaking the hyperparameter and user parameters essentially, and improving the optimizing the particular model itself. The crux here, what I'm saying is, the crux here is, it is the data acquisition, it is the data cleansing problem, it is a feature engineering thing which takes 70 to 75% of your data science life cycle, essentially. And then as a further maintainable activity is a model monitoring comes into picture, right? And that is the reality in any industry. Okay. So just to, kind of a recap, you understand the business, you understand the problem, you collect and explore data, right? You prepare and process data, as I said, and this is the one basically which takes most of the time, 70 to 80% of the time, these steps essentially, right? And if I try to again visualize this whole process essentially, right? I mean, you have the particular acquisition understanding typically, right? And you have the data sources, understanding of the business, which has the pipelines you create, you wrangling the data, you clean data, explore data, you clean data, right? And then you do the kind of modeling over here, which needs the feature engineering part, ensemble techniques of model training, multiple models coming into picture, evaluate the models, check their accuracy, check the model is overfit or not, etc., etc. And then you start doing in the customer acceptance model deployment is concerned. Okay, that's how the overall cycle or a data science life cycle would look like essentially, right? In fact, I have one more diagram to show that thing as well. Let me show, that will be also easier for you to understand. Mm, one sec. Yeah, this one. Yeah, you listening right now currently, right? This basically the part of what I was discussing right now, right? So you start from problem identification, right? And you start the understanding of business, and then you have the data acquisition thing coming into picture, right? And then you would say that you understand the data, and that is what I was saying earlier, right? Visualization not only helps over in the last mile, but visualization also helps in doing the data analysis is concerned. And then start the feature engineering perspective and all those things, and then you do the model creation and training, deployment, and there is can be issues where the data drift, that whatever data you expected down the line in when you're doing the model deployment and model training, what you get in the actual production thing is maybe a bit different, right? So you have to keep on optimizing that particular thing itself as well, right? So this is the typical structure or a life cycle which is applicable across, generally across all projects, all use cases, right? The data can change, the data set can change, the data type can change. It can be image data, it can be audio files, it can be JSON data, it can be for a structured columnar structured data like that, right? But how do you handle that in the modules? That remains as it is essentially. Okay. Okay. Yeah. A data science team typically, right? A data science team, this is a kind of a happy scenario, right? So when you work with your your interns in your colleges, with your folks, with your students, when you impart your knowledge across to them, right? I mean, the common thing happens that I want to be data scientist, sir or madam, I want to be an analyst, etc., right? How they fit in the overall industry, right? And that's how the structure looks it. And obviously there are issues over here as well, that in some organizations, due to budgetary problems, they kind of combine the roles of many of the roles over here into one person, etc., etc. But this is a more of a happy, good to scenario you have, right? You have a data architect who's main job is basically, of the data perspective of the data understanding, data architecture, right? And they typically work with the data engineers essentially to acquisition the data itself. Again, as I said, that the leveraging of data scientist or a full stack data scientist basically is coming in data architect, data engineer typically, right, as well. You have a DB administrator from the load balancing of data, the scaling of the databases, how to handle making sure the security is taken into consideration, data is available to a 24/7, the data integrity is maintained properly, etc., is typically handled by a DBA. Right? Data analyst typically is more of a junior level analysis perspective, who are not responsible for the business communication or the impact is concerned, right? And this guy or this person essentially is like to analyze, do the expert data analysis, the pattern, the correlation at one level. And the data scientist basically is the one who combines all these things. As I was saying earlier, it combines the knowledge of programming, combines the knowledge of statistics, combines the knowledge of the business acumen expertise, combines the knowledge of, the part of analysis of data, algorithms, right? And puts together a solution to the analytics team or the stakeholders essentially. Statistician typically very fixed kind of role over there, or what hypothesis testing has to be done, or what inferential statistics has to be done, what algorithms should be used, which will handle this kind of mathematics and hence give these results at that level. Business analysts, or typically many things called as data consultants as well, they are the ones who are more on the business side compared to the data side itself, but they have to know data as well. They are the ones who, in service organizations, they typically talk to the clients, right? Understand their problem, etc., along with data scientists as well. But they are mainly on the overall business side and how your data science solution is helping to create the business impact. And finally, the data analytics manager typically is the one who is overviewing all these things together, who is kind of understanding the team. And many a times I've heard the question here that many talks have been delivered, that does the manager have to be, or technical? The answer is, it is good to have, not must to have. Good to have in the sense that if you are speaking the same lingo, the same technology terms with your team, that will add into your respect essentially, to be very honest. And if you speak only at the function level, at delegation things, at managing things, it would work, it won't be that effective. That's also true. So data analytics managers or data science managers or ML managers typically, right, they need to be data centric. They need to understand the business for sure, 100%. I'm not saying they have to understand the algorithms at a scratch level. For that, they have a team. But they should know that what's happening inside out, right? Not at a code level, but at a flow level typically. That would help, to understand that whatever my team is delivering today and whatever the functional aspect is over there, apart from their existing role of managing the whole team, is it what it is asked for? Is the requirement being matched by my client or my stakeholders, right? So that's the whole, purview of a data science team, typically, how they work along, how they're gonna gel along should be. This one, yeah. Okay. Okay. A very interesting slide, right? And I would ask you questions on this as well, for just for discussion purpose, right? What does this tell you? What does this slide tell you? What do you when you read these lines over there and the numbers given over here, 1, 2, 3, 4, 5? What does it tell you? If, like, let's say if you're in an organization, right? Let's say, what does it tell you? What these numbers denote? Okay, it's in the chat box. Level of understanding. Okay. I would use the word, Dharmendra, level of maturity or level of data maturity, I would say. Correct? Okay. Lower to higher level of maturity. Correct? Exactly. That's what I'm saying right now. A level of or levels of maturity. Correct? Okay. And getting detailed insights. Okay. I'll park that for a moment. Sahil, I'll park for a moment right now. Okay. Any other thoughts here? Okay. So, as I
So
said, yeah, go ahead.
it's a moving from information to just like towards the knowledge or wisdom.
Very well said. Information to knowledge or wisdom. Correct. Right. And this also tries to, understand or map. If I'm talking about a data driven organization, right, where they use data for all kind of decision making purpose typically, right, how they would take it forward, right? I mean, how they would move in a level where their data's understanding, data's maturity grows slowly and gradually from a very basic of descripting and reporting kind of thing to a kind of cognitive kind of thing, essentially. So what does it mean? Let's see. A descriptive typically, right? Descriptive tells me basically over here that nothing but historical data. What has happened in the past? Right? I mean, you use visualizations, you use a lot of tools, reporting, BIs, and the report will tell you, even for patterns, correlations, it will tell you that what has happened in the past, right? That's level one. So that is basically after you have done the due diligence job of collecting data, typically, right? After that or post that, right? This is something, and the reality again in the industry is that you will see, I mean, a lot of organizations, right, in the industry, and now every organization is, AI enabled, they are ML enabled, right? And I'm not saying anything bad about that, but I mean, it's just that everybody wants to be in this hot space in the market. And that's how they kind of portray, that's how they market themselves, right? Even they do the simplest of Excel reports, they are AI enabled, and that's how they put it. But the reality is, many of these organizations, in fact, majority have, many have seen that they, not majority, but quite a few have seen they do real AI stuff. They do real AI, machine learning stuff. They help the customers and client. They have products around it, etc., etc. But majority have seen, even they do, basic BI and reporting, they call them AI enabled, right? And that's how the truth, or that's how the reality is, right? Again, going back to a point over there that, okay, now we understand that and descriptive what has happened, right? And the diagnostic typically in a form of advanced analytics, but it comes kind of hand in hand with descriptive as well, that why it happened, right? You talk what has happened in descriptive, and I talk about why it happened. Now, drill down techniques or data discovery. Remember that thing of we talked about the visualization of the cargo daily. You kind of deep dive into it, find the correlations again, right, and drill it down, and that will give you some answers that why it eventually happened. Okay, right, and then after you have that level of maturity, right, you start slowly building the fact that, okay, good, now what can happen next, or what is likely to happen next right now. Okay, so in that case, what happens over here, I'm trying to give the prediction angle over there, right? I'm telling basically what can happen next. I'm trying to do some kind of estimation, some kind of forecasting, some kind of prediction angle into it, right? Some kind of scoring models comes into picture, right? So I had what has happened. Now I have said why it had happened, and now I'm telling what is likely to happen next, right? Then comes the part of prescriptive analytics. Okay, you have told me what is probably would happen next, right? There's such a long statement over here. It basically says that what should you do essentially, right? What would your business, what should your business do about a specific instance to avoid, some hazardous situation to avoid? That's prescriptive. The same way we should give prescriptions and by giving the doctors that this is what you should take the medicines, this is what you should do, what you should not do, right? Same way in data science and machine learning, prescriptive analysis is nothing but what is that you should do and you should not do or avoid, right? Some kind of, let's say, recommendation systems typically, right? I was talking earlier in the e-commerce business typically, or in OTT platforms, what you should watch next, isn't it? What you should buy next, what you should buy with this particular item. Those are nothing but recommendation systems. So you are prescribing to the user what he or she should do next, right? Now, after all this happened, right, and then comes the sweetest of spots, right? Sweetest of spots of machine learning, of NLP, and distributed computing, right? That is what we typically call nowadays as the deep learning, essentially, right? It's something like this: the way we as human beings respond or maybe react sometimes in certain scenarios, right? How our brain inferences from our past knowledge and gives an answer. If that is being pushed into a machine, right? And how they would react to it. That's exactly where a lot of research work typically is happening in deep learning, where just like our brains typically, our brains consist of what? Our brains consist of, a lot of the particular dendrites, the neurons, the synapses signals typically, right? And they are all connected neurons together, right? And that is exactly, yeah, Shaman, that is exactly what we're talking about deep learning, nothing but neural networks, where you don't have to supervise always, right? You do need a lot of data, absolutely, but the inferences I will draw will be very, very similar how you and I would draw inference in a particular scenario. And that's exactly what I'm saying. It's a combination of machine learning, NLPs, and distributed computing as well, right? One example here, right? The self-driving cars, correct? What is a self-driving car, by the way? And what do you think is applied over there? Any guesses? The Teslas essentially, right? The self-driving cars you have heard about or read about it. What does it do?
Cars have the abilities of taking the decisions.
The car will take the decisions on its own or on the behalf of the particular drivers, correct?
Yes, sir. Yes, sir.
Okay, good. Now, how does it do that? I mean, basically, in the sense that, let's say, robocars, complex deep learning models, correct, Dharmendra? But in terms of, let's say, it drives on the particular road. It's on the road right now. How does it understand? That's a green lights traffic signal versus a red light, right? A human is there. Somebody is crossing the road. There is a car beside in front of me. There's a building over there, right? Uh, Basically, just an example over there, it is able to detect objects automatically, right? So obviously over here, it's able to detect objects automatically, meaning it's able to also automate the autopilot software. Yeah, that's fine, but Shama, that but the underlying technology being used essentially, it's using computer vision or image processing over here in the heart of deep learning typically, and that's typically called as CNN or CNN networks, essentially neural networks, and they have recurrent neural networks as well, multiple of them particular thing as well, and those kind of technologies, those kind of deep learning convolutional neural networks, correct, uh, CNNs, RNNs, recurrent neural networks, implementation using TensorFlow and Keras, right? Those are the ones, and even PyTorch from Python. Those are the kind of technologies who are being fed with numerous, yeah, there's RCNN and there's also RNN as well, recurrent neural networks as well, and the combination is called RCNN typically. And not only that, those combinations typically are fed with innumerable knowledge set labels typically, right? And that is where they're able to make sense of the particular data, making sense of a particular perspective of making a decision as if it's a human who's taking an inference out of the whole scenario essentially, right? So that is where the industry is trying hard or trying go to that level, starting from the descriptive, very basic, what has happened, 1, 2, why it has happened, diagnostic, 3, tell what can happen next, predictive, 4, what you should do, what you should avoid, 4, and 5, you don't tell me what has to be done, I will take a decision on my own. That's how the things move typically. Clear? Clear, everyone? Okay. So in this particular scenario, you'll hear a lot of words coming in, right? From the buzzwords, you'll hear a lot in the when you read about it. NLPs, deep learning. I said earlier that machine learning, deep learning, machine learning subset of AI itself, right? And deep learning is a subset of machine learning actually. And image analysis is part of deep learning. NLP is part of machine learning as well as, I mean, NLP can be applied both for ML and deep learning as well, right? Now, having said that, right, and as I said, right, machine learning is a field in data science where machines can learn themselves without being programs, right? It's a data-centric process. So what are the things you do? As I said earlier, you gather data from various sources, you change the data, you clean the data to have homogeneity in nature, you remove noise in data perspective, you select the right ML algorithm, you gain insights from the model's result, right? You then put across visualizations to transform the results into a more appealing story and a relief story from that particular thing itself, right? Now, some examples over here, right? Machine learning techniques, right? There's a lot of techniques over there. Classification problem, right? Let's say you have a classification kind of thing, examples. Now I'm coming to the classification or machine ML techniques slowly and gradually. You have talked about, let's say, classification problems, right? Based on the training data and having observations, right? I'm able to understand that with known categories, the classification predicts the category to which a new observation belongs. That means, for example, I'm trying to predict whether the price of a house would fall. Okay, under which class? It can be very costly, it can be costly, it can be affordable, it can be cheap or very cheap. Right? This is a classification problem, right? It's a multi class basically. You don't have single class, you can have multi class over here. Another example. Predict that my new applied customer in my bank will be defaulter or not. Yes or no. That's a pure binary classification. Yes or no. Okay. Another example. Loan approval. You have applied for a particular loan. Will we approve it or not? Obviously, again, under the purview of different history that they have and the history customers. And the current guy who has applied for the loan, he has given certain data in a structured format. I will say that my machine learning model tells that there is a 80% chance he will be given a status yes, or a 20% chance he is a loan, a no, etc., etc. Those are pure classification problems, right? When you have a discrete set of values, categorical in nature, that is where you try to find out the classification. Clear, everyone? Any other examples which you have in mind, which probably would be helpful to tie the knots? Any other examples which you have in mind, which you want to talk about in classification? Okay. Regression problems. Predicting a value. Okay. Or see, forecasting is also prediction as well, but it's in a time space, right? Forecasting typically means when, on what date or one particular time unit, what would be the value. So you're predicting in time space, but regression is more about predicting value when a new value comes in. That means, for example, predicting the price of a house. If the house is in this location, this is the size of the house, this is the time of buying, etc., etc., what would be the price of the house, right? So any continuous variables, right, when you're predicting, is typically called as regression. Any categorical variable, which is basically something like yes or no, predict rainfalls, absolutely, Sonali. The weather forecast typically, right, is a forecast. It's a prediction with a time space essentially, right? Classification is basically around categorical variable. What is a categorical variable? Anything which is basically discrete in nature and not continuous. Example, yes and no. Example, a apple, banana, and let's say jackfruit, for example, right? Three different values, discrete values, right? Again, classification can also be complicated as well. That means a simple record, one line record in Excel, can have multiple labels. Example, an article on the blog, right? Classify fraud image, absolutely. An article, for example, right, you're seeing in the blog or some other post, right? This article talks about what? Okay, this article talks about sports around 50% of the time. This article also talks about politics as well. Good. This article also talks about athletes as well. So that record or that document is basically a multi-level classification. You are assigning multiple labels for that particular thing itself. Right? Stock market trends, Lalit, absolutely. Stock market trends typically as a level of forecasting, right? Over a period of time, with the last history data, I'm kind of a train over there. What is my forecast for this particular stock in the next 15 days? Forecasting, prediction, essentially in that time space. Okay. These two are clear. Classification and regression. Able to understand with the real life examples?
Credit card transactions.
Credit card transactions. Okay. What? I mean, if you can elaborate the case, that will be helpful. If you can elaborate more, I mean, a fraud or not, you're saying, is it correct? Or is that what you're saying? Possible fraud or not?
Yes, sir.
Absolutely. So it's a classification or regression problem?
Regression.
Think about it.
Classification.
Sir, but whether the transaction is fraud or not, we will identify it now. We will identify the amount, place, type of purchase.
What is your target variable? It's fraud or not, correct? Yes or no?
Yes, sir, yes.
Okay. So you're classifying a record, it's fraud or not?
Yes, yes, right.
Variable, so it's classification problem, correct? Now, to do that thing, your input variables can be multiple. Input variables can be, or the features or the independent variables can be a mix of continuous and category. It doesn't matter. But your target variable you're doing, basically you're predicting is fraud or not. So you're classifying a record. Let's say I had an example. I mean, I myself had a personal example. Around 3 years back, I had had to do one transaction, which is generally not my particular limit, which went around beyond a certain level of transaction essentially, right? And straight away these guys call me up from the ICICI bank, right? I mean, is it you have done? Generally, they never call me up like that. Is this transaction which you have done? I said, yes. What is your date of birth, etc., etc.? They call me a particular thing, right? This is what. So they verified the fact that it's not a fraudulent transaction. So they had basically what happened the moment they did a transaction, their ML models or their particular machine learning models would have triggered, let's say, X% chance that there is a transaction on Anshu's credit card, which can be a probably 80% chance to be a fraud, and which sends notification to the particular customer care, they call me straight away. Right? That means the systems are over there kind of tied up together, right? And the ML are built on my history of transactions, that it is I who have done this particular thing, and suddenly there is a spike of the particular amount I spent one time on credit card, which doesn't fall into my existing pattern of my data. Hence, there's a chance of the thing as a particular fraudulent transaction. Make sense?
If the example, the problem statement is that from alphabets from A to Z, the algorithm is expected to identify the input is an image of any of the alphabet.
Got it.
So this will be A to Z 26 classes, and so it is classification, or
absolutely
okay, or the outcome is considered as an continuous because
no,
26.
No. It's a classification problem, and it is specific to CNN typically. And I have, if I'm not wrong, I have seen this example multiple number of times on different blogs and forums, right? Where you show an image of a letter, typically it detects an A or B or C, like that thing. It's a very, it's a kind of a hello world example of deep learning, right? Where they use image classification, image, and I use the word image classification, right, to understand what the letters is. But it's definitely a classification problem.
Okay,
and
thank you.
It's a basically a not only thing, it's a multi-class classification problem, right? So basically you're not saying yes or no, you're going to have 20. So I said earlier, right, it's a multi-class. I mean, it can have multiple classes essentially.
Okay, thank you.
Yeah, Dharmendra, customer, oil price prediction, Archana, is definitely a continuous regression problem, right? Dharmendra, customer buying behavior. Customer buying behavior. Okay. Is this a classification problem, Dharmendra, or is it regression? I don't think either of them, isn't it? It's more on the lines of segmentation, or it's more on the lines of particularly, clustering, essentially, right? Who are the customers who have similar kind of behavior, buying behaviors, right? So when you say clustering, right, assigning a set of observations into subset of clusters, so that this cluster, based on the whole record, this, all the attributes, they have a similar kind of buying pattern. So I mean, clustering's one of the major importance, or major goals is basically, think about it again. You have thousands of customers, for example. Is it feasible, or is it practical enough to design your promotions, your campaign strategies, your marketing techniques, to design every customer by customer? Is it practical? Is it possible? What do you think? You have 1,000 customers or more than that, or maybe 1 lakh customers. You need to have to increase your sales, increase your brand value, increase your product sale, etc. You need to have campaign strategies, promotion strategies, marketing strategies. Is it possible and practical to have those strategies done for at a every single customer like that? Is it possible? Is it practical? Absolutely not, right? That is where these kind of clustering helps, right? I mean, uh, when you cluster them, right, you'll be able to know that, okay, this is one cluster, okay, and I see maybe I have put around, let's say, 100 customers in one cluster. That means they have some kind of similarity. They have some kind of, whether it's a buying behavior or the kind of products they are buying, when they are buying, etc. They have some similarity over there. So I can, well as create some kind of promotion strategies, campaign strategies, which is for that cluster, which is more feasible compared to, yeah, the group of customers. That's what I'm saying with clustering over here. Inflation rate of next decade, yes, we can, provided we have the last decade's data completely at transaction level of the inflation rates as well, right? But over here, the complicated factor would be, it's a very good point, Vishal. Over here, the complicated point over here would be that, what are the external factors will you take into account when you're predicting the inflation rate, right? I mean, think about it, right? I mean, COVID-19, for example, right? Have you ever thought of COVID-19 coming to place in India or any other country in the world so far? Never. Because we never had that history data behind it. We never had that kind of situation happening ever. We never had situations of this kind of disease, uh, which had so much of an effect, essentially, right? And this, which means that where ML fails, where my deep learning fails, right? Because I did not have history data, essentially, right? I didn't have this kind of thing happening. I could not consider this situation happening, yes or no, just by a pure classification, because the history data was not there. We didn't have similar kind of things at all happening at a period of time, right? Those happens. At the same time, there are models, there are financial gurus who do this in terms of the economic depression happening on the line, right, in a particular period of 10 years or 20 years, right, where they take a lot of external factors into picture, right, the environmental factors into picture, and there is a possible X% probability that this is a depression happening, or economic depression or final depression happening over there, essentially. Okay. Again, recommendation systems, right? Use the ML algorithms to help you find a new products, and gave a lot of examples on OTT platform, right? And recommending you certain movies based on watching patterns of people. You cluster the similar users again, right? And you Amazon suggesting the products you're buying based on popularity, those kind of things. Anomaly detection, that you have data, you are doing a pattern of data. What I see is missing over there is that it does not conform to an expected pattern or other items, right? And outlier or anomaly is called a credit card, as I said earlier, right? Could be a potential banking fraud, definitely possible. Dimension reduction, the process of reducing the number of random variables, right? I mean, which is, we were saying earlier, feature importance, right? You have 10 features, for example, right? You have one to predict. Let's say, for instance, you have 9 input features, one to predict. So out of these 9, how many are important? How many are significant? There are tools in the Python or other products as well, completely, which will tell you that, boss, to predict this variable, out of these 9, maybe 4 are more important. The less, other 5 are less important typically. So that is basically the overall gamut of ML techniques in the purview of supervised learning and unsupervised learning, and these are the ones which are majorly used across the industries, and every particular technique has their own algorithm typically to handle the particular technique, to classification problems. Or one interesting bits over here, right? Netflix, you might have heard about it, right? Long time, I mean, not long, maybe around 10 years back or 7 to 8 years back, they had a hackathon challenge it for anybody and everybody, for students of engineering colleges, interns, right? And they had given a particular data set. They wanted to find out that what is the best recommendation which you can give. Is anomaly detection related to classification? Yes and no. Why yes? Because detection of anomalies, typically they say that what is the chances of being this particular anomaly itself, right? And what they do, they use that output of anomaly detection, it's anomaly or not, right, to the part of as an input variable for classification. That means I'm saying it's an anomaly detection over here. Yes, it's an anomaly. Okay, good. If it's an anomaly, then is this particular record helping me to understand if I'm trying to predict it's a fraud or not? Does it help to answer the question, Sonali?
Yes, sir. So is it like that we find the patterns in anomaly detection?
Correct.
Yeah, we search for a pattern to find an anomaly, and then we classify it as an whether anomaly is present or anomaly is not present.
Mhm.
And then is it?
Basically, I mean, you can think in two ways itself, right? You can think that that record itself is an anomaly, and when I'm doing the ML classification, it's an anomaly, and hence it tells me it's a fraud or not, one way, right? Or the other way, I can say that I can have one variable over there. So I'm basically granularizing or modularizing the whole technique itself. I'm saying that, okay, you first tell me it's anomaly or not. I say yes with a 80% probability, and then use that particular variable essentially as my input variable to my fraud classification purpose. Right? Okay.
Yes. Yes. Thank you.
Okay. So supervised learning, unsupervised, talked about it, right? So whatever we talked about, classification, regression, recommendation, are mostly on the unsupervised part of it, and unsupervised is more in terms of the clustering. Essentially, it's more used, right? It does not predict anything. Essentially, it's understand the data, understand the patterns, segments of the entities, and that type of thing. Interesting because you don't have anything to target as such. Reinforcement learning, an approach to AI, it's kind of reward based learning. A very good example is chatbots, right? You say an answer, you ask a question, you give an answer, you answer it correctly, you reward that, you answer incorrectly, you don't reward that. So basically learning from the positive and negative reinforcement, right? And the machine learns how to act in an environment essentially, right? Okay, there are different techniques typically, which we will discuss tomorrow and do a bit of hands-on sessions over there as well. We'll take up tomorrow on linear regressions and logistic regression and some on clusterings as well. Ensemble will take as well, right? And the Netflix challenge typically used a lot of ensemble learning essentially and do the job. So I think we're at the end of the hour today, right? I'd like to put aside last 5 minutes today. Any questions, any thoughts on the pace, any suggestions? Would be happy to take it now.
स्टेशनला जायचं 4 वीसची पॅसेंजर पकडायची 9 वाजता 8:15 लोकमोडीत पोहोचायचं 9 वाजता घरी पोहोचायचं 5 वाजता तिथनं निघायचं 7 वाजता पॅसेंजर
Can somebody go on mute, please? Anisotropic diffusion filtering techniques for noise removal. I can take that up. I didn't have that particular thing in place, but I'll take that up for sure. I'll take that. Right? But obviously, I'll take a separate time for that thing. Yeah, I will do that. I'll share it with Guru Sonali and he can share it accordingly. Okay. So no other questions?
Excuse me, sir, will you provide any study material?
I can. I have these PPTs essentially, right, that I can share across. And also I have a lot of online books, PDF essentially. I can share that. And also have a lot of cheat sheets I have used in the like a one pager or two page form, kind of summarize the thing, but I can share it as well. Okay.
Yes, sir. And one more question. That is, after this course, that is, we will train on in this. That is, we will learn most of the things. And in students' perspective, So how we can teach to the student, or which topics we have to tell to the students, so that they can make the career in the data science, because it's that is ocean, so there are n number of technologies. So how we can guide the students to do the career in the data science in the beginning? So
a lot of ways. There are 101 ways typically, actually, right? And if you see on the online courses available as well, right? Maybe what you can do is that you can probably be a very good guide essentially for the students, right? You can there can be two ways possibly, in terms of you can direct them to some kind of online courses. There's a lot of free stuff available in courses as well. And what you can probably guide as to student, that when they do the online courses, probably you can help them in creating the projects and real life projects, possibly with a data set essentially, and help them to build that, apply those algos which they have learned in those online courses or whatever you have taught them to up. So be a guide in terms of not from the courses directly, but more from the applicability of these algorithms on those particular industry case studies. That would be helpful.
yes, sir. Sir,
Because, yeah.
can I make one request, so that if you take any use case, like suppose if we take the telecom domain, so from starting to end, can you take this type of use case, so that we will get the idea of?
Sure, absolutely. Absolutely. I'll do that. I'll do that. Don't worry. I'll probably do it on the third day. That'll be easier. By that time, you would have learned or gone through all these techniques and all those things. That'll be easier to connect the dots.
Okay. Can you suppose if you give the prior idea, so we will study or we will read something about it, so that it is helpful for to learn when you teach it.
Sure, I'll do that. I'll do that.
So
normally practical assignments which we have it is the house prediction prize. So it's a typical email spam or ham. Again, we are taking the data set from Kaggle, which is already almost clean. So where we are facing challenge when we are teaching this subject, as you said, 60 to 70% of the part is data pre-processing, whereas that in most of the problem statement, we are having a very cleaned kind of a data set.
Exactly.
So it is totally separate. Like we are here informing the students about missing data or one hot encoder, and whereas in the assignment, we are not using that kind of a data
Exactly.
set. So if
I think, yeah, agreed. I got it. So basically, emphasis more on the data analysis part rather than the modeling part, essentially, right?
Yeah, absolutely, absolutely.
Correct. And that is a reality in the industry. I mean, that way.
Yeah. And about object detection, most of the time, as you said, CNN and all those algorithms are used. Whereas in text specifically, if you could help us in maybe text summarization or a few assignments related to text, that will help us a lot for conduction of the subject.
Okay. Text analytics particularly, right? Like it can be about topic detection as well automatically, right? That is one particular part. Text summarization, right?
Yeah.
In fact, if I'm not wrong, have you seen the GPT-3 by OpenAI?
No. GPT-3. Okay.
You should.
Okay, I will just write. I know about topic modeling and few techniques, but again, it is.
I mean, topic detection is LDA typically is used, right? A lot of is being used over there. Some also techniques, but try this NLP, this new thing coming and has come. It's a giant for deep learning and NLP. It's called GPT-3. Okay. So have a look about it. It's kind of
deep learning.
GPT-3. GPT-3 space. I'll just write it down over here. That'll be helpful.
Okay.
That's right. GPT, I just put it on.
Okay. Thank you so much. We'll definitely go through.
Sure.
So, yeah, thanks a lot, sir. We will be sharing. I'll be sharing tomorrow's Zoom link, and those I would request. I have sent a faculty feedback form as well. You guys can fill that in, and I'll be sending the tomorrow's link. Day after tomorrow, we will not have a session. Maybe tomorrow we can discuss on third day when we
correct.
can do the.
We can do that. Correct.
All right. So thank you so much, everyone, and thanks a lot, Anshuk sir.
Thank you so much.
Yeah, we really appreciate your patience, and you have taken us through the entire end-to-end of it. So really appreciate it. Yeah, recording I will also share after taking permission from Anshuk sir, provided you guys have to give the feedback and also testimony as well. Then I'll definitely share the recordings. That's it for now, and I will be ending the session. Thank you so much, everyone.
Thank you.
Thanks.